ಎಷ್ಟು ಸಾಧ್ಯ ಇತ್ತು ಅಷ್ಟು ನೋಡ್ ಮಾಡಿ ಬರೋದು. ಸೊ ಪ್ಲೀಸ್ ಐ ವಾಂಟ್ ಟು ಹ್ಯಾಂಡ್ ದಿಸ್ ಫಸ್ಟ್ ಹೆಸರು ಅವ್ರ ಹೆಸರು ಹಾಕೋ ಹೇಳಂಗೆ ಅವ್ರ ಹೆಸರು ಹಾಕೋ ಅಷ್ಟೇ. F2 ಹೊಡಿ ಅಷ್ಟೇ, ಪ್ರೀಮಿಯಮ್ಗೆ F2 ಅಷ್ಟೇ. ಡಾಟ್ PPT ಬೇಡ. Darshan? Darshan? Oh, what's the problem? It's hanging. Karan, K-A-R-A-N. Go first.
ABHI and Abhinav. No, it's not Abhinav. ABHI and AB. ABHI and AB. AB.
ABHI
And AB.
and AB.
And AV.
ಎಲ್ಲ ಈಗ ಕಲೆಕ್ಟ್ ಮಾಡಬೇಡ ಅವ್ರು ಬಂದಾಗ ಪೆನ್ ಡ್ರೈವ್ ಕೊಡ್ತಾರೆ ದರ್ಶನ ಹೇಳಿದ್ರೆ ಇವಾಗ ಕಲೆಕ್ಟ್ ಮಾಡೋದು ಸ್ಕ್ಯಾನ್ ಮಾಡೋದು ಸರ್
ಅಲ್ಲಿ ಕಲೆಕ್ಟ್ ಮಾಡಿ ನಾವು ಮಾಡ್ಕೊಂಡು
ಕ್ಯಾಮ್ರಾ ಸೆಟ್ ಮಾಡ್ಬೇಕು ನೀವು ಅದನ್ನು
ಕ್ಯಾಮ್ರಾ
ಕ್ಯಾಲ್ವಾ ಬರೇ
PPT ಮಾತ್ರ ಬರ್ತಿದ್ಯಾ
ಇದು
ಯಾವುದು
ಇದು
You have it in email. Have you mailed the PPT? Your friend has got it. Actually, you particularly mentioned as virus free.
It is virus free only.
But how come you
I don't know what happened. Okay, I'll get it through mail within 5 or 10 minutes.
Yeah, fine, not an issue. We have internet over here.
Okay.
You can ask him. Or you can ask ask Vinod. Vinod, Vinayak sir, Vinayak sir, We'll put it
Yeah, correct. If you can clear this place, I'll check the camera. No, this one.
ದರ್ಶನ ಯಾವಾಗ ಬರ್ತಾನೋ ಅಸೋಸಿಯೇಷನ್ ಏನು ನಡೀತಿದೆ
ಫಸ್ಟ್
ಯಾರು ಟೀಮು ನಿಮ್ಮಲ್ಲಿ ಯಾರು ಟೀಮು ಯಾರ ಟೀಮು
ನಾನು ಮತ್ತೆ ಸಂಗೀತ
ಇಬ್ಬರಾ ಶ್ರುತಿ
ಶ್ರುತಿ ಸಿಂಗರಾಗಿ ಮಾಡ್ತಿದ್ರು ಆದರೆ ಡಿಬೇಟ್ ಹೋಗಿದ್ದಾಳೆ ಬರ್ತಾಳೆ ಲಾಸ್ಟ್
ಶ್ರುತಿ ಟಾಪಿಕ್ ಏನು
ಇಮೇಜ್ ಪಾಸಿಂಗ್ ಅಂತ ಇಮೇಜ್ ಪಾಸಿಂಗ್ ಏನೋ ಸಮಥಿಂಗ್
ಹೌದು
ಇಮೇಜ್ ಫ್ರೇಸಿಂಗ್ ಸಮಥಿಂಗ್ ಏನೋ ಗೊತ್ತಿಲ್ಲ ನೀನು ಒಬ್ಬನೇನಾ
ಸಮಥಿಂಗ್ ರೋಬೋಟಿಕ್ಸ್
ಹೌದಾ
ಆಲ್ ದಿ ಬೆಸ್ಟ್ ನಿಂಗೆ
ನಿಶಾಂತ್ ಏನಾಯ್ತು
ಅಲ್ಲೇ ಹಾಕ್ತಿದ್ದಾರೆ Start here, sir.
This one. Sanju Shan. J. This one J. one he sent it to me. I should have sent him back. Because in this I think the picture is missing.
Picture is missing.
Yeah. This one that the
We shouldn't have deleted in the browsing center.
we put it over there and
We are not allowed to put a pen drive. Morning and lady told us.
but we anyway put it in.
Yeah, because that guy wasn't there. That guy was in his folder. I think that's not the thing. Or why don't you call him and tell him to send the mail? Is he at home?
No, I have my copy of signature. I'll download that.
Does have a photo?
Yeah. It doesn't. Maybe it's there. I can't see it.
Download and read it. Yeah, open it. No, don't open it. It's a folder. Yeah, it's there. Is this the one?
It'll be there. No, this is my.
The final one? How did it get virus?
I have no clue. That pen drive is like even this one.
So you want this one or that one?
The two papers, one after this.
ಇದಾಗಲಿಲ್ವಾ? ಇಷ್ಟೊತ್ತು ಆಗಿತ್ತಲ್ಲ. ರೈಟ್. ಓಕೆ ಓಕೆ ಲೈವಾ? ಇಲ್ಲ ಆಗಿಲ್ಲ, 7 ಗಂಟೆ ಕೊಡ್ತೀನಿ. Okay.
I downloaded it.
Live or not? Okay. Rules are like this. You will be given 10 minutes total. In total 10 minutes for your presentation. Wherein approximately 12 minutes. Wherein 10 minutes just for your presentation. 2 minutes for your question and answer. This will be asking you questions you need to answer. That's 2 minutes. So for 8th minute there will be a bell for the 8th minute. And for the final 10th minute we will have another one. Okay? Got it? 8th minute we will have one bell, warning bell. 10th minute will be the final bell. Any more doubts? Fine, we will start off. Who will do this? Yeah?
I think someone has to take care of that.
Live start ಆಗಿದೆ. Okay. Yeah, I'll yes ma'am, 2 minutes. Yeah.
ಇರ್ತಾರೆ ಮೈಕ್ ಪ್ಲೇಸ್ ಹೀಟೆಡ್ ಆಪ್ಷನ್ ಹೀಟ್ ಆಗಿದೆ ಹೌದಾ ಆಯ್ತು
today in this 10 minutes of presentation, we'll be focusing on the introduction of a basic brief introduction of what is cloud. Then we'll discuss why cloud, cloud services, applications, evolution of cloud. Hello? So in this presentation, we'll be focusing on the introduction, which is a brief introduction of what cloud is, then why cloud, its services, evolution, then top cloud service providers in the market right now, and the final conclusion, the summary on the cloud. Introduction. Cloud computing, a style of computing in which elastic IT-enabled capabilities are delivered as a service to external customers using internet technology. This is a complete nerdy, geeky definition given by Gartner. Gartner is a renowned American agency which does the research and advising firm, which is the most leading in the market right now, which gives the recent service on cloud computing, virtualization, and big data. Yeah, this is the Wikipedia definition of cloud. Cloud computing is nothing but a cloud where you store the data on the servers and you access it whenever you require it, and it's connected via internet. So what basically is cloud computing? You take a picture, go upload it on Facebook, Flickr, Picasso, or any else a social website. What you do is, indirectly you are using cloud computing. So whenever you go back to the Facebook and click on that, you get your picture back. So what happens when you go upload it on Facebook or Flickr or Picasso? The photo you uploaded is stored in the data servers, which is kept in some big warehouses with a large number of servers which are nothing but high-end computers, or which have a set of racks where each rack has a motherboard, its own ventilation, heat sinks, everything, and together it acts as a giant CPU. So when you store the data on the cloud, you can access it whenever you require. The data can exist at one place, 3 places simultaneously, or tons of places simultaneously. You never know whether your actual photo is safe until and unless you go back to the website and click on that. So this is basically our idea of what cloud computing is. Why cloud? Why use cloud when you can have your own servers at home offices? Why do you use cloud when you have your own servers at offices? The reason is, small businesses, startups coming up, they have small budgets and they want to take, for example, they're coming in ads, they have designed apps for companies, they can't afford to have high-end software, servers, administrator to manage the servers, and a different server group for that. For them, all they need is just a cloud service provider, and the famous cloud service provider right now is AWS, that is the Amazon Web Services. So when you just have the cloud service providers like those, you don't have to worry about managing a company. You can start with a friend and you can just give them a call. They will read your data for you. You just have to focus on developing your app and focus on that rather than the storage part or the updation part or the hardware or the software problems. Next, services offered by the cloud. There are 3 basic services offered by the cloud, and they are SaaS, PaaS, and IaaS. Where SaaS is software as a service, PaaS is platform as a service, and IaaS is infrastructure as a service. SaaS. Any of you have used Google presentation or Google spreadsheet? None of you? So that is SaaS, where an online application is already available on the internet. You just log in, you use it, you modify it, you save it, you come back. Again, you want to change it, you log in, you modify it, then leave it. So that is a SaaS, where software or the application is already up and ready on the cloud. You just log in, use it, and log out. An example for the again spreadsheet and presentation. Platform as a service. Google App Engine. Have you ever used Google App Engine? Google App market right now. Benefits of cloud. Obviously, so if you have a startup and you want your business to grow and you want to expand your business but you're not much on monetary thing, obviously cloud is the only option for you right now, because that's the only thing which you can have for the software updations and no hardware problems, and basically they handle everything for you. You're just one call away, pay the rent a month and you're good to go. Cloud by 2015. So cloud has approximately, in 2014 it has a market of, in 2010 it had a market of $4 billion US, and by 2030 it is expected to reach a mind-blowing of $270 billion. So while that, by 2050 it's going to reach more than 90% with $170 billion. So right now cloud is the biggest market, cloud is the biggest popular or whatever you call it, the main thing on IT right now. So, and the data storage, cloud data storage is right now, in 2010 it was around 1.1 zettabyte. Zettabyte is 10 to the power of 24, which will reach to 4.8 zettabyte by the end of 2014. So that's how fast cloud is growing. Who's who of cloud world? So this is the main top companies, the big shots in the world of cloud computing. As I mentioned again and again, Amazon Web Services leads the market by a major role. Amazon Web Services are the leading in the market right now, followed by the Google Drive and the Racksat, and there's Cisco coming up. Cisco is the new wave in the cloud, you can say, because it's just realized the importance of the cloud and trying to tiptoe into the world of cloud computing. So, conclusion on cloud. We don't need cloud, do we? We don't need cloud, do we? You work in an office, you have your computer there, you log in there, you work on a confidential project, you come back home, you do change it. What do? You go back to your company, go open your computer, log in and change it and write whatever you want. Wrong. If you have cloud, you can do even the confidential projects at your home, and there is no security issues involved. And that is our main pro, where you can store your data securely, though there is some security issues, but the encrypting of the data has always restored. The cloud is as safe as any other software on the internet right now. So, by all of this we can say that cloud, we are in the PC era. It's not a personal computer anymore, it's a personal cloud, because cloud is the new computer. Far from going, that is the most the other thing is, but when it comes to security, they also say that many agencies say that no software is uncrackable. Like everything is encrypted, but nothing is uncrackable. So that's the thing. That's the reason cloud has some existence, because everything is at stake. Nothing is safe on internet. So cloud can. Yeah, Gmail is the simplest and the most used service.
What are the service models of a cloud?
Just public cloud.
Anyway, you will discuss in your slides. Thank you, Dharma. The next participant will be Karan Saxena, first year CS on Windows Phone OS.
Good morning, all. So I'm Karan Saxena from first year Computer Science department. So the topic of my paper is Windows Phone, and what comes in your mind when you first ask this new phone coming up in the market with this hype created? Very first thing you want to ask is which operating system does it support? Right? The major players in this market is iOS, Android, and Microsoft Phone OS. So the contents, I'll be discussing Microsoft Phone OS today. The contents of my presentation will be the introduction, the history of the OS, present version of the OS, previous versions, and the change log. Features of the present version of the OS, how is it different from the others, Windows Phone architecture, Windows app architecture, and then the conclusion. So, bit of history about Microsoft. So, developed about Windows. So, developed by Microsoft, Windows Phone OS is an operating system for mobile devices. It includes the core OS, that is the OS, the middleware, that is the interaction between the hardware and the software, and the key applications which we get bundled with the OS. In terms of market share, it covers about 7%, which is a good share since it's a new player in the market. And the support is of Q4 2013, and it's a closed source commercial proprietary software. So, how it all began? So, Microsoft began work on its handheld devices way back in 1990s. As a result of the efforts that Microsoft put into development of computers and into putting computers in the hands of people, work came upon on Windows CE. So with the dawn of 21st century came Pocket 2000, which was the polished version of Windows CE, and which was codenamed Rapier, and it was based on Windows CE, which was the initial version, and version 3.0. Present version of the Windows Phone is the 8.1, which is the current generation of Windows Phone, and this was showcased in the Build conference in San Francisco on April 2nd, 2014. Abbreviated as Windows WP 8.1, its successor of WP 8.0. All phones currently running 8.2 will be upgradable to 8.1, but not vice versa. So the previous versions can change now. As already discussed, the very first version was Windows CE, codenamed Pegasus, and it was the initial showcase of Microsoft's vision of an operating system for mobiles. Next came Pocket PC 2000 in 2000, which was intended mainly for PC devices, and it supported a quad video graphics array, QVGA resolution, and external memory cards. This was released on multiple architectures since Microsoft wasn't sure on which architecture mobile future will depend. Pocket PC 2002, which included Windows Media Player 8 with streaming capabilities, a Microsoft Reader, and a new Pocket Outlook. It had enhanced UI, Team support, and sailor-built downloads from the Internet Explorer. Next. So Windows Mobile 2003 came in 2003. It included Bluetooth device management, a new Windows Media Player 9 with a MIDI, that is multimedia interface for digital multimedia interface for digital instrument support, and Pocket Outlook with visiting card and visiting calendar support. Windows Mobile 2003 second edition, it came to make wireless access more secure, Wi-Fi pocket protected access, and an array of new screen resolutions were also supported. Windows Mobile 5, which came in 2005, the new version of Office Suite was included, along with the new release of Microsoft Windows Media Player. Hardware features were enhanced with Bluetooth support, default QWERTY keyboard support, and a management interface for GPS. Photo caller ID's feature and direct show was also integral supported. Windows Mobile 6, it introduced Windows Live and Windows Exchange 2007, and it included Mobile Office 6.1, which also supported the extensions for Microsoft Office 2007. It showcased storage card encryption and support WBGA resolution. Windows Mobile 6.1 was a minor upgrade from Windows 6. Windows Mobile 6.5 was intended to bridge the gap between Windows 6 and yet to be announced Windows 7 because Microsoft was archiving Windows Mobile series. Versions 6.5.1, 6.5.3 and 6.5.5, the three minor upgrades to version 6.5 before Microsoft finally archived Windows Mobile phones. So coming to the Windows Phone series, the first version was Windows Phone 7, which added CDMA support, fast application startup, and Facebook integration. Windows Phone 7.5 code name Mango. So it was a major update. It included a mobile version of i9, multitasking of third-party apps, Twitter integration of the People Hub, and Windows Live SkyDrive access. Windows Phone 7.8 was debuted in 2013. Since Windows Phone 7 was not upgradable to 8, and Microsoft was about to announce 8, so they gave this update, and the features were backported from Windows 8 to Windows 7. And these included resizable home screen tiles, more accent colors, and improved marketplace and an Xbox Studio. Windows Phone 8, debuted in 2012, allows speed resolutions up to 1080p, supports near-field communication, NFC, and backwards compatibility with Windows 4.7. It has improved support for removable storage, redesigned home screen, resizable tiles, and new wallet hub, and first-class integration of voice-over Internet protocol applications. It ships with i10 and has a special driving mode so that users who are driving are not distracted, and the phone automatically takes all Linux calls as per the command of install. So Windows Phone 8.1, which was announced in Wisconsin, San Francisco at the WIT conference, the key features of 8.1. It came with a plethora of new features. The one most notable feature was the introduction of Cortana. It's the virtual digital assistant which is similar to Apple's Siri and Google's Google Now. And it also has a workflow keyboard which has a shape writing capabilities, and it currently holds the world record and it smashed the swipe record made on Samsung Galaxy S4 by 8 seconds. There's also deeper Skype integration and allows one-click voice call animation for Skype call. There's a new Sense app which comprises of data sense, Wi-Fi sense, and the storage sense. New notification center known as Action Center has been added for Windows 8.1, which was missing in Windows 8. It also has new battery saver apps which claims that even after 20% battery remaining, the phone will still work to make calls for next 24 hours. It adds a mobile version of i11 as a default browser. It also adds support for closing apps by swiping them down to making it a true multitasking capable phone. Unlike Android, when you close the tasks, so when you close any service, it isn't really closed. If Android wants, they can restart it. In Windows, it's not. You can just long press the back button. It opens a list of current applications. You can just swipe them down to close it completely. And it also added support for VPN, Wi-Fi direct, Bluetooth, low energy. Built-in battery meter enables users to check detailed stats of how the power versus power consumption. On the UI front, Windows 8.1 has now 3-column layout, unlike 2-column layout in the previous versions, and with changeable wallpaper and plenty more customization options. And regular features are included in Windows 8.1: messaging, storage, web browser, streaming, additional hardware support with GPS, accelerometer, gyroscope, magnetometer. The marketplace, Wi-Fi, Bluetooth. Windows 8.1 supports Wi-Fi direct along with Bluetooth low energy. T3 users can now allow the phone to be used as a hotspot. How is Windows Mobile OS, Windows Phone OS different from others? When Microsoft archived Windows Mobile, one of the reasons was that it felt that the uprising open source software in the market was catching up. So Windows had to do something to make it apart. When Microsoft was planning Windows Phone OS, one of the main questions was to keep it open source or not. Since Windows and Microsoft then took the middle way, it did not allow the code to be open source, but it allows the release of the beta versions, which the being closed source, it preserved the knowledge and experience of great programmers and software developer engineers, while the beta testing of the code allows some great ideas from general public to float. Hence, the end user gets the best of the both worlds. So there's a comparison between different OSs in a glance. So there's no music store in Android, while iOS has iTunes, but Windows Phone 7 has Zoom, and Windows Phone 8 has Xbox streaming capabilities. So Game Center, social gaming, iOS is supported by Game Center, Android does not have it, and Windows Phone has Xbox Live, and these are some other things. Next. So what's the phone architecture? Windows Phone 8.1 relies on Windows NT kernel, unlike Windows Phone 7 which was on Windows CE kernel. So Windows NT kernel Microsoft violated because it wanted a seamless collaboration between the desktop version of the OS and the mobile version of the OS. Windows kernel NT is primarily written in C, C++ and assembly language. Mobile layer has been done away starting from Windows 8.1, making it seamless between desktop and phone. So any app which can run on desktop can run on phone, and vice versa, which was not possible in Windows 8.1 and before. So then there's Windows Core layer, which comprises of NT kernel, and then there's Windows Phone layer, which comprises of connection management, which handles the Bluetooth, Wi-Fi, and the radio chips, connection management, platform services. There are like package manager, execution manager, navigation server, and resource manager, which handles the basic functionality of the OS. The apps, there are inbuilt apps that is email, push service, Facebook integration, Twitter integration, and auto updates of the apps are handled by this layer. And on top of that is the Windows shell, which includes the UI. Next. So applications are primarily written in C#, C++, JavaScript, and Visual Basic. Frontend can be written in XAML, HTML, or DirectX if games are being designed. Majority of Windows apps rely on .NET framework for a common compilation process. Windows 8.1 doesn't fully rely on a just-in-time compiler, unlike like Android, which also doesn't have a just-in-time compiler. Instead, it uses a cloud-based optimizing compiler that automatically generates an almost done code when the user uploads the binary file in the Play Store. Sorry. Yeah. So, and these are native images for all apps are quickly finalized on the phone itself in order to produce a native executable, which are then compiled just in time, making it not a fully just in time reliable phone. They are compiled just in time and the app is run. Next. Yeah. So conclusion. So backed by a powerful and reliable Windows NT kernel, the desktop version, the Windows Phone OS is no doubt one of the best mobile operating systems in the market. Deeply integrated social networking features make this OS very popular among the present generation users. And most of the applications require internet access, hence keeping them connected in real time. Applications can make use of the hardware features, accelerometer, gyroscope, hence making the results more user-friendly and accurate. Windows Marketplace allows users from more than 120,000 app options to make sure that people from all categories actually make full use of the OS. Next. Yeah, so future of the Windows Phone OS, one of the main questions here.
You have to confine, and also this 10 minutes presentation means you make a plan, prepare 8 or 10 slides. If you take a 1 minute, 1 slide, 1 minute, 10 minutes will become over. If you put 70 slides, definitely it needs, even if you read, it needs 20 minutes. There is no scope of explaining it out. Okay. Next time you plan for 10 slides, maximum of 10 slides. Okay. Now your time is up. It's a question of time. Okay. How is Windows Phone has got a superior features compared to Android OS?
So Android is an open source OS, right? So when in open source or in public,
You get the superior features.
yes sir. So I'm comparing between them. So the Windows is closed source, right? So when something is closed source, so it automatically has great features which are included from the SDEs, and public is not able to modify them. As well as the beta testing of Windows Phone, this module, the marketing scheme of Windows, the beta testing allows great ideas to come in, hence making Windows Phone OS more user-friendly, as well as it has great security features which come down by experience of great developers in the company. And apart from that, Windows is keeping all the updates to itself. It does not allow hardware manufacturers to push updates. Windows has OTA updates over there, Microsoft directly pushes. So that makes sure that the manufacturer.
What is the market share?
So the market share of Windows is 7% as of Q4 2013. So as comparing to Windows Phone was released in 2010, so it's I would say that this is a really great catch-up. So, and this market, so which is now rapidly developing with Windows 8.1, I'm sure Windows will go along with.
Reasons for Marcos to go away is this one. He do well in phones.
Which company is using this Windows
So,
Phone?
see, you are telling it is closed and more security in that. Open source and all is a loophole for that. Okay, but popularity is Android, right?
That's for the mass.
Windows, though even though it has no security.
Because it's comparatively a new platform. Android was introduced back since it's established in 2004, right? It's a new platform, and I feel like the rate of catching up is pretty fast, right? And we can say like why people use Android is more popular because of the price it comes. You can get a 4K Android phone, but you cannot get a 4K Windows phone, right? And Build Conference Windows has announced that it's releasing Windows freely for under 9-inch devices. So this is one more route that Windows is pushing to capture the smaller market. Because you cannot have a 4K phone when you have to pay the price to put the OS. Android comes free, you do not have to put the price.
Did you buy Windows phone?
Yes, I already have one. Thanks a lot.
Thank you for this. The next contestant will be Chaitanya Prakash from third year ECE. The topic is gesture control robot using image processing.
Please remember, if there is a small bell, you can take clicks up.
Yes, sir.
Every time you may have to put the slides. Come to the conclusion. Conclude it.
Yes.
Okay.
Or 6, 7. Not working.
Good morning guys, I am Chaitanya Prakash and I am from 6th SEM ECE department and
What's your duration?
1MV11 ECE 061. Okay. Today's most innovative part in the technology is robotics. So can anyone tell what robotics is? Anyone?
Simply present.
Sir,
We are not a lecturer.
okay then. If
You have 10 minutes only.
yes, sure, sir. I'll get up. Okay. It's if Chaturangam and 3 days were given a task of defining robotics, he would define as a branch of technology that deals with the design, construction, operation, and application of robots as well as the computer system for their control, sensory feedback, and information processing. But most of us don't understand what it is. So, robotics is a branch of technology that deals with developing automated machines to replace humans in most dangerous and repetitive task processing processes. So, most of you have gone through line 4 and robot, 4.0 robots. Those are main and robotics projects that you have done. But the main challenge is that most of us in robotics face is accuracy, efficiency, and accessibility and next slide. Accessibility and feasibility. Okay, what is accuracy? It is how accurate your system is working for the task that you have defined it for. And efficiency is how efficient your system is utilizing the available resources. And feasibility is the cost criteria, that is how feasible are you in implementing the project. And the final thing is accessibility. That's the main thing in robotics. It is how you access the robotic systems. And since the past decade or so, gesture control and image processing has gained major importance. And in my project, I have included gesture control to control robots. And this is a prototype, and I'll tell you why I have done this. Okay. The main basic flow of the system is like this. Images are captured through webcams, and these are processed using Simulink, which is block diagram. Okay, it is processed using Simulink, and there is a code generated, and this code is transmitted to the robot using a transmitter, RF transmitter. And once the robot receives it, there is an interrupt call for which there is processing done, and depending upon the code received, there is movement of the robot. And okay, the main technologies that I have used in implementing this project partially is Simulink, RF module, MVIT, and L293D. What is Simulink? Simulink is block diagram environment for multi-domain simulation and model-based design. I have used this Simulink mainly to reduce the hardware cost and make it effective. And the next is RF module. It does, as the name suggests, it works at the radio frequency of about 434 megahertz, and I have used this to transmit the code generated from Simulink to the robot via various interfacing. And the next is MVIT EPU. It is microcontroller developed by FL company, mainly for robotics field, and this is got on 8 This is got on 8 kilobytes of self-programmable flash memory, 5 kilobytes of EEPROM, 1 kilobyte of internal SRAM, and it goes on. Then we have, I used L293D to run my motors. This is basically a simple block diagram, and it has got an H-bridge electronic circuit there, which can drive the motors into two directions. That is, H-bridge uses to H-bridge applies voltage on the load in either directions. So when the load here is the DC motor, so by reversing the direction of the current flowing through it, we can change the direction of the motor. Next slide. Okay, this is the main design implementation flow diagram. The webcam captures the images. Okay, gestures are developed from the hand basically. So the webcam captures images of the palm, processes it, uses erosion, dilation, block diagrams from the Simulink, and generates the code. And this code is then transmitted to the robot via the RF module transmitter. And once there is the interrupt called by the MVIT microcontroller used, there is an interrupt called, and there is a processing done. And after this processing, there is the signal is given to the motor driver, which then helps in movement of the robot. Okay, the main advantages of my paper is that most of the hardware cost is minimized because I am doing most of the implementation, simulation in Simulink. And the next is it provides a real-time gesture inputs, and I am using an ordinary webcam that also minimizes the cost. The main thing is the future scope. Most of you all might have heard about microfluids. Microfluids are used mainly to generate electric power. And if that is a good success and if it's working efficiently, then I would like to implement it in my tires to generate electricity that is sufficient to drive the DC motors. And the next thing is I will use a red tape on fingers. That is the redness in the hands vary from person to person and from place to place. So having a red tape will lower the threshold value of the image that I am taking in from the webcam. The next is the disaster management. There are many places which we are not able to access. So using this robot, we can control the robot from the control station, and using this robot, I can navigate to various places. Then the next is security and bomb tracing, where the most dangerous part is bomb tracing, and so I can deploy my robot to find the bomb and help it defuse it. Then the last and most important thing is to implement it using a wheelchair. So the robot is a miniature of actually a wheelchair. It has got 2 wheels and so on. So if this is a success and if the implementation is easy, then we could implement the same thing. We can flaunt it into the wheelchairs and then have it into a more effective way so that those who are physically challenged, maybe in their legs, so we can help them move in the society freely. This can help them become more independent in the society. And finally, I would also like to implement robotic arm, but it is not possible right now. I am trying to implement the robotic arm, that is to control a robotic arm which can lift an object, place it in another position using just images. And this has been in research right now, and most of the projects are done already. Next go. And concluding, main aim of my project is to provide a novel way of life to these people instead of life to these physically challenged people, so that they don't depend on others and they don't become a pain and stress for others. So in this way I can help them move about the places around. And thank you for your attention. Any questions? Sir, that is the testing area. If that is successful, then we would go and implement it in testing area. Sir, but the hardware part, when you are trying to test it on a hardware, if there are any faults, then the hardware cost will increase. But if you are doing it on a simulation, most of the simulation is done there. And if it is successful, then we try to implement it in the hardware part.
So what type of sensor you are using for tested?
Sir, there are no particular sensors, sir. There is just a webcam from which webcam and the Simulink, the basic block diagrams from which I am processing the image, and then there is a code generator.
Okay, once you capture an image, you may expect it.
Yes, sir.
Just
Here, sir, once the image is gotten, there is redness of the image, and the threshold value is created for the image. And this gives in only the redness of the image, and others are made black using CR module.
So you are comparing this.
Yes, sir.
You are comparing it.
I am not comparing anything. I am just
Image or capture?
no, just a count that counts the number of fingers available in the gestures. And using this count, I am going to transmit to this count to the. That is the specialty of the Simulink, sir. There are like there is this one, sir, and there is an image from our hand, and there is an outline of the image, and this outline of the image will help us count the number of fingers.
what is the maximum it can count?
It can count till 4, sir. And this is like this. Sir, that doesn't go because I'm mainly concentrating on the movement of the robot, that's forward, backward, left and right. And so the main thing is only 4. And you put an extra finger or anything as such, then there will be an error and there will not be movement of the robot.
Thank you, Chaitanya. The next paper will be on wearable technology and its scope by Hitesh Verma and Abhinav of third year IS.
A very good morning to all of you. And today we are going to have a talk. Today we are going to have a talk on the topic wearable technology and its scopes by me, Abhinav, and Hitesh Verma. So 1LV00, IS001. One LV IS001. Yeah, we have IS001. 001.
001.
Yes.
So in this
You are splitting it 10 minutes to 5 minutes.
Hello. So in this seminar we are going to cover these topics, which are what is wearable technology, types of wearable devices, and Google Glass types of wearable devices. We have divided. There are so many types of wearable devices, but out of which we have selected two. The first one is Google Glass for obvious reasons, and the second one is Fin. Fin is an Indian product, that's why I have chosen this. And the last one is future of wearable technology. So let's move on. What is wearable technology? The minute we hear this word wearable technology, the first thing which comes in our mind is a cool device and of course the Iron Man and kind of stuff. So of all mega technology in recent years, wearable technology has generated the most number of headlines and hypes. Obviously for good reasons. And the thing is that wearable promises a future where we are no longer equipped with heavy laptops and smartphones which are easy to use. So the thing is, a lot of things have changed since the development of first computer. The first computer is like the first computer. Because nowadays the computer this is just introduction, and introduction I'll tell you a lot of things have changed since the development of first computer. Now the computer has got more powerful and more efficient. They can be pocketed and even they can be wear as a fully associated, kind of gadget, like dual glass. Before moving towards the future of this wearable technology and things like that, let's have a look on the evolution of wearable technology and
Hello. Good morning everyone. So I will talk about the evolution of wearable technology. Basically, it started by the London College of Fashion and Technology, where in 2018 started a technical fashion show. In that, people who were very gadgets, lectures using belts, headphones, goggles and all, etc. From there, the basic idea of wearable technology got into existence. And you can see from 1980 and still it's going on, people are working on the wearable technology from huge gadgets to tiny handy gadgets. It's handy gadgets because it's very handy. Okay. Since working now in Google Glass, and many products are just launching like transfer information. So basically, I will tell you about the basic model, the block diagram model. The basic is this: the CPU thing. The microprocessor CPU with the both input devices and display device and the main thing, the video camera. It senses the environment and recognizes the object. I will tell you what is the main difference in the later half. There are different types of wearable devices which we are being known. Google Glass. This is the main product which I want to say about. The most emerging and interesting product. Introduction. Google Glass. Google Glass is a technical masterpiece which works on the voice command technology. Basically, it's a wearable tiny computer which uses the same Android software which we use in our Android phones, tablets, etc. Okay. The basic main purpose of using this thing is that is providing hand-free information display. The hand-free thing is that no use of hands, you just use the displaying of information in the screen, and it's currently available to the most smartphone users. And also it allows interaction with the internet, social networking, etc. everything and all via natural language voice command. Basically right now it's in English, but later on in the future it would be in the all regional languages or the languages in the world. Yeah. Evolution of Google Glass. The emergence of Google Glass came from the land volume system developed by the US Army in the past decades. It was named head-up eye display, or I can say head-up mount display. You can see it was the base structure of the Google Glass. Now this is the simplified structure, what we call Google Glass. Next. How it works? Basically, the main function of Google Glass is the use of the mini projector and the clear prism. You can check out the projector is there. From projector, it will display the content on the prism, and via prism, it will be reflected directly on the retina. Okay, so it will reflect in the visual package in front of you. It's just like a visual layer over the reality. So it's just what we can see is just a visual reality. Basic parts. The Google Glass basically communicates with the mobile phones and other devices using Wi-Fi, wireless technology, and it displays the content on the video screen, which you can see, check out. And other things, the main important thing is that the video camera. Again, I tell you, senses the environment, it senses the object and it tells the detail of the object and it recognizes the object. The basic thing about is the CPU. Is the main microcomputer part which you know about basic personal computer CPU. It's the micro CPU. Okay. You have a microphone because all the command works on the voice command. The device works on the voice command, so we have the microphone with that and a speaker for that. Uses. Basically, as you see, there are 4 clips. The first clip, I will just say that you will never get lost again. With high technology GPS system inbuilt and the voice command, you don't have to look down to your mobile phones. Basically, you can just check out you have to go for the location, it will display it on your screen. Basically, it's very handy when you are driving. When driving or physically handicapped person. Or you are walking in a rusty streets and all, when you want the location. So basically, it's a helping thing without the use of hand. Just as I call it, it's a tiny computer, handy computer, because Google team has squeezed all the computer features into a small tiny package of glass. Okay. The second thing in big is that it's no more now setting the camera and opening the camera and all and missing the moments without any snap. You just have to order a command, okay glass, take a photograph. It will have a photograph and you can share it in Google Plus, Facebook, even in the video calls you can share with your friends. That's one good advantage of using the voice command. The third thing, that's the main thing I wish I call barcode identification technology. It's just replacing text-based searching. You don't have to text for a search in Google search. You just check out the barcode, it will detect the barcode. From the barcode, it will tell you all the details about the object, what the price, what about the expiry dates, what about any products and all. The last thing is that about the contacts and the details. There are many people who have many mutual friends in Facebook, but they don't know about information of that person. And you are about to meet that person. Google can give you that Google Place profile page of every person and contacts of every person. So again, you can just make a start with the introduction. Next. Yeah, basically, this is the future of the technology of virtual reality. Augmented reality. It's nothing but it's a live, direct or indirect physical environment in which the elements are augmented and sublimated using the general technology of computer, sensors using computer just like sound. Okay, sound, graphics and images. That's the future we should be today's era of virtual reality.
The next device is Fin. Fin is the tiny hybrid product that we can wear on our thumb, and the basic idea behind this Fin is next slide. You can see the prototype. It's Fin in the ring. It's stuffed with a lot of ICs and sensor. So this Fin is having the capabilities. It will make your whole palm as a sensor and gesture sensor. So all you have to do is just to make a swap or kind of tap, and it will recognize it and will send it to a connected. Will send a command off to your connected devices. So its benefits. Let's see the picture. We can see that the Fin has a multiple device compatibility, like for smartphones, smart TVs, auto voice, and home automation devices. So even for Google Glasses also we can require Fin. Because Fin, Google Glasses works on the voice command. But in a crowded place where a lot of people are there, and if you want to give commands, it's worthless. So this Fin can be used at that time to navigate through your Google Glass. So last slide. And the future of wearable technology. This is a very interesting topic. Today these wearable technology are just used to see or take information. In future they could be used to control the devices around us. That means it's all about creating a superhuman. Well, that doesn't seem an overstatement, and the days of seeing the real Tony Stark is not too far. So a lot of companies have already started investing on these kind of prototype suits and all. And the thing is, the coming future, don't be surprised if you see people flying here and there just using their suits and all. So this is one of the technology. It will make your whole palm as a gesture control. It's like all you have to do if you are doing some kind of thing, you are having earphone in your ear, and you want to change the time. What you have to do? You will have to take your phone out of the pocket and select playlist, and you have to hit on the button next, right? With the all you have to do is just swipe like this and the song track will play. So very often.
How can I differentiate my gestures then?
No, it's the thing is that it is having ring is having lot of ICs and sensors. So what will happen? At first, when you install this system, you can assign particular part of your palm as a particular thing like what you want to assign to the.
Using projector. Projector is not harm your outside you are using projector. Will not harm your eyes.
No, sir, it's not harming because actually the projector, what I say is the thing is that the projector will be just in this part and all, and from that there's just a simple reflection of a general what you see in the TV, the display lights and all. It will reflect the prism, and the prism will reflect minimum light on your eyes. So it would be very used. I have seen a glass and I have just tried also my so it was the light or the intensity is just according to the human perception of eye. So just adapted to the human perception of eye, and you will have definitely work on it, and many people are using it. And hopefully in India it will be launched soon, so people will be working on it. One of the disadvantages is that it is completely covered the voice command. So definitely the
when you're waiting, you have to concentrate on what is going to display in front of you. Suppose I'm walking, while walking, if I use Google Glass and the display will be in front of me, so I should concentrate on display or I should concentrate on the road.
so much that SD quality is very much
Display
here.
is involved.
Now it depends on how you deal with how you use the technology, because the SD quality display is so much clear that even if you're using a Google Map, it will show your blue line and it just show your transparent blue line. You can walk out.
Sometimes
Yeah.
concentration will go.
For something but won't be affected even if some other person coming in front of you, because the person will be easily visible. Yeah. So if it's easy visible means that the person is coming in front of me, I will just get a direction. When I get a direction that some person is coming in front of me, so I will control that way, my body will control that.
Google Glass was augmented reality.
So actually basic concept which I was from Google Glass,
It is augmented reality.
but the basic idea is developed from augmented reality for that. And now the future is that using the connect technology and all. Now it's developing in gaming technology is that I can interact with virtual and reality and all.
The next paper is on wireless communication 5G technology by Tanu Bharadwaj and Shruti Jain of third year series.
Good morning, I am now present here. I am Bharadwaj and my friend Rohit Jain are here to present a paper on wireless communications 5G technology. In this presentation, we will be talking about introduction, then evaluation, then 5G network architecture, advantages of 5G, connectivity with 6.25. Clearance is 125. So we will be talking about its advantages, the challenges and task conclusion. So basically, what is 5G? 5G is a wireless communication networking which operates in the 5 GHz frequency mode. It is built on the 808.11 AC IEEE wireless networking standard. That is nothing but our Wi-Fi. So basically, a new Wi-Fi standard has been defined for this 5G technology. This standard provides better flexibility, reliability, range, and coverage. It has got high incredible transmission speed, it has got high quality video streaming and instantaneous data syncing. This communication system could be supporting real wireless World Wide Web. Nowadays we are using WWW, that is World Wide Web. But we there we can expect www, that is 4W, that is wireless World Wide Web. Next slide. So evolution, when we talk of evolution, we are having 0G, 1G, 2G, 3G, 4G, 5G. You can see the devices being used. When we talk of 0G, 0G refers to pre-cell phone mobile telephony technology such as radio telephones that some had in class before the advent of cell phones. So basically when we talk of 0G, it had implementation only in the car. It could not get across beyond cars. It was confined to cars only. When we talk of 1G, 1G is first generation of wireless telecommunication technology which was developed in 1980s. So when people saw 0G, they started implementing or modifying the architecture and the different speeds, and they got 1G. It was based on FDMA, that is frequency division multiple access. So what we study in our computer and network subject started with this FDMA 1G. It is also popularly known as cell phones. Here we started developing cell phones. It replaced 0G technology, used analog radio signals. 1G had low capacity, unreliable, and poor voice links. But nowadays, when we talk with phone with our friends, that time it was something like there was eavesdropping. You can third party to have heard your talks with your friend. So there it was. There are incident was there. This was this poor voice links. Then the security system was not robust, as there was always a chance of eavesdropping by third party. Second generation services included SMS messaging and the services provided by 1G. So when experts started developing 2G, they took all the services of 1G and then they implemented this service called SMS. But different ways of transmitting data such as email were still unknown. Their emails and we can see Bluetooth, those things were still unknown at that time. The modulation schemes like TDMA and CDMA were used. TDMA is nothing but our time division multiple access and CDMA is nothing but our code division multiple access. Transmission speed was limited up to 64 kbps. Thank you. It is based on International Telecommunication Union family of standard. The standard which has been defined for 3G is ITM 2000, that is ITM 2000. Then it introduced new ways of transferring data such as video calls. Nowadays we use 3G, we get WeChat, we use WhatsApp. So basically the functions which we use in nowadays in smartphones and iPhones is nothing but our 3G technology. It delivers speeds up to 14.4 Mbps on the downlink, that is nothing but our downloading, and 5.8 Mbps, that is nothing but our uploading. 4G has been launched in India by Bharti Airtel in collaboration with Apple, 5S and 5C. Yeah, they are providing this service at 3G passes only, that is most commendable job. And they are providing more bandwidth than 3G, designed facilitating improved wireless capabilities, network speeds and visual technologies over end-to-end internet protocol. Here we are going to have a wireless communication that is, and somewhere we are going to have a better speed than 3G. The downloading speed is up to 100 Mbps. 4G devices support IPv6 addressing. IPv6 addressing is a protocol which we use nowadays and we will be using in 5G also. But IPv6 will not find the most best platform in 4G. When we talk of 5G network architecture, it includes the user terminal, a number of independent autonomous radio access technologies. Each rack has its own interface and is seen as an IP link to the outside internet world. So every rack, that is radio access technology, will be having a different IP link, that is IP address. Protocol setup of the new levels within the existing protocol stack which form the proposed architecture is presented in the figure. So we are using a protocol stack for this protocol setup. Here you can see that we are having a reconfigurable multi-mode terminal, that is a user terminal for the users. Then we are using some services provided by our service providers, that is GSM, GPR, Edge, Wi-Fi, WiMAX, and etc. Then they are connected with some cloud computing things, some databases there, then some services are there, that is multi-use, multi-learning, multi-government, multi-commerce, multi-portal, etc. When we talk about its advantage, we are going to use IPv6, that is, it is going to provide an IP addressing bit of 128 bits. There are distinct care of mobile IP addresses assigned according to location and the connected high resolution for the cell phone users. Now, through remote management offered by 5G technology, our user can get better and faster solution. Now, imagine a situation, if I am a farmer and I want service messages from my experts, those who are there in Ministry of Weather Forecasting. So, if I can talk to those persons at that point of time, I can know what will be the weather today, tomorrow, so our harvesting will be good and our product will be good. Then it has got implication in health field also. Patient can talk to his doctors at that point of time will be. 5G technology can provide large broadcasting of data in gigabyte, which supports almost 65,000 connections. That is 128 bits at the speed will give 65,000 connections. Now the point of 5G comes. More spectrum must be pressed into service for increased capacity and demand. Since as the capacity will increase and the bandwidth will increase, a lot of spectrums will be needed. Networks will become much denser with many more cells, raising the overall performance of networks, which includes combining the evolving new 5G wireless system with radio access technology. Now, RATs and the Wi-Fi standards has to be combined with the ongoing research. Due to the presence of single port infrastructure, high redundancy and security entities are required. If we are going to have a single port infrastructure, and in that only we need to manage traffic control, etc. Conclusion: 5G technology is going to be a new revolution in wireless system market. The new coming 5G technology will be available in the market at affordable rates. That is, we are going to experience 5G technology in just 40 or 3G rates. High-tech feature and much reliability than existing technology. Okay. The future scope includes wearable devices with artificial intelligence and sixth sense technology. So basically, nowadays we have read about artificial intelligence. Today, when 5G will come, artificial intelligence will find a platform for it. You can see less resources and best speed will be given by 5G, 2G, 3G, 4G, all will be behind, 5G will go ahead.
How do you define crazy cell phone?
That's why we need more resolution. We want more speed. We always need better technology.
So what better technology is not crazy?
The students nowadays young generation, they want movies. So we already did this.
Even if you want to give an introduction, you have to finish the introduction in one slide, maximum of 2 minutes. Because your topic is 5G.
But you will talk about all the facilities
now provided by 5G.
Because basically a difference what we are getting in 0 to 4G and 5G, what we are getting extra in this 5G. So it is all about that. What the radio speed and the bandwidth we are getting here.
What is the main advantage of 5G over 4G or current 3G speeds?
We can be able to download the movies the same also. That is expected by the experts.
Also the battery will also be saved.
It's energy efficiency.
Because only 1 second will be taken to download a movie. So we not waste the time. The computer will do the work. Korea is working on it. It will be around 2020. Korea will announce in 2020.
What parameter is it? 4G, 5G. What parameter?
Speed and bandwidth. Bandwidth also, then traffic control.
Security also. Yeah, security. It will be more security.
Energy harvesting from passive human power using reverse electrolytic by minimizing.
Give that in the
My crew members are Pawan and Manoj. The USNs are listed over. Okay, let me start my presentation by giving a justification as to what active power is, what passive power is. I will give you two practical scenarios. First one, the active power. Say we are playing tug of war. We are deliberately putting this mechanical power. So that is active power. Deliberately we put this power. Whereas when you are walking, you want to walk ahead and about 40 watts of power are being wasted for one footstep. So this is passive power. We are not deliberately doing it. We need to walk, so we need to put that pressure. So coming to the first slide, evolution of this passive power utilization. First of all, it all started with piezoelectric method, which was started in 1800s after the introduction of piezoelectric crystals. And then after knowing the cons of that method, we went on to dynamoelectric method. And we all have seen this Nike shoes which these children used to play with. As soon as they press it, light appears. That was the evolution of dynamoelectric method. And then the recent one, reverse electrowetting method using microfluids. There is a field called reverse electrowetting. There is a separate field called utilization of passive power. Our concept is like we mix both of this to generate a new concept. Next one is piezoelectricity. Almost all are aware what piezoelectric effect is. You apply some pressure, mechanical power, and then there is some disturbance in the internal lattice layers of the crystal, and then internal charge will be generated, which can be harnessed. That's how the piezoelectric effect goes. So yeah, initially after the introduction of piezoelectric crystal, they used this idea in escalators or some malls. They implemented this, but the failure was piezoelectric crystal can't handle if the pressure goes beyond certain limit, piezo crystal breaks off and the capacity decreases. So we had to resort to some other method. The next method came dynamoelectrics. Dynamoelectrics is more concerned with mechanical and using this dynamo part. A flap is there, you apply some pressure, there is a spring which is kept, and there is a mechanical part which is fed back to the some gears. This gear, after the rotation, will charge using the dynamo, will charge the battery unit. That's how the technology goes. And one thing, as I said before, Nike shoe was one example of this dynamoelectric prototype. But the problem is the spring. It has a spring constant which gets degraded after say 10,000 cycles per second or something. So this is one thing. And if you apply a lot of pressure, the problem is spring breaks up and it's a total failure. So our concept is reverse electrowetting. We make use of microfluids. Let me tell you the concept of microfluids. 1 microliter of a particular fluid being captured in 1 micrometer of space. So the way it behaves, say water, it is macrometer in length, macro field. But we consider this microfluid in micrometer. So the way it behaves is totally different. Capillary action in phloem xylem. How it works. This is microfluidics. And the thing is, it has more efficiency. The surface tension, how it shows, is entirely different. So regarding electrowetting effect, it's very similar to piezoelectric effect. There is change in surface tension, thereby change in the contact angle of the fluid with the electrode. As you change the potential difference between this electrode and it's almost same as piezoelectric. You apply some pressure, you get voltage. But here, electrowetting, you apply some voltage and the surface tension is fixed for that particular voltage. But we are resorting to reverse electrowetting. It's the ulta concept. You change the surface tension and you get the voltage. That's how it goes. And regarding electrowetting, the problem, the concept is, the wetting mainly depends on the surface energy. Surface energy is like the extra energy which is present on the surface of the liquid in addition to the bulk, the potentials. So that's how it goes. And regarding the surface energy, it is explained mainly by Lippmann's equation. Lippmann's equation is one thing which we are making use of, and then to consider this contact angle thingy. we need to concentrate on this contact angle. Surface tension depends on contact angle. So this two concepts can be merged by using a relation between Lippmann's concept and Young's modulus. Young's modulus is for springs. It's mainly for spring action. So we are mixing this concept of Lippmann's equation and Young's modulus so that we get both piezoelectric effect concept as well as this dynamoelectric, spring action and piezoelectricity. So both are compensated using these two formulas. Next slide. So reverse electrowetting. We know by energy conservation rule that if you transform one form of energy to another, it can be transformed in the other way also. Giving you one example, if potential energy is converted to kinetic energy, it can be converted to kinetic energy back to potential energy. That's what law of conservation says. If electrowetting works, definitely reverse electrowetting should work. If you change the surface tension, we are getting some voltage. That's how the concept goes, core concept goes. Next slide please. This is how it is. That is the fluid, conductive fluid between electrode. We are changing the surface tension of that fluid and then we get one output voltage. Next slide please. The droplet. The main thing with this droplet is as soon as you supply some say pressure, the contact angle immediately decreases. Pressure, contact it becomes flat. So the surface tension becomes low. We are maintaining a constant DC bias voltage of around 3.7 volts, and what it behaves is like a capacitor, variable capacitor. They are just varying the distance between the plates. Put pressure, the distance between the plates is reduced, and thus the voltage is changing. Next slide please. So that is how it goes. Fluid between two electrodes. Vary the distance, get some other voltage. So 3.7 volt maintain DC bias voltage, change the pressure, and automatically you get the extra charge. From the capacitor, you give it to the battery unit, and then you can harness it. Next slide. This is the observation which was made. For different frequency values, frequency with which you press, and for different voltage, bias voltages, what are the different energy densities which are recorded? That is how the energy goes. The graph goes. One more thing is, after 60 kgs of pressure, the output energy density will remain constant. So even if you press 150 kgs of pressure, nothing will happen. It remains at the same output power. Out of 40 watt power, the power which you put, out of which 20 watt power will be effectively utilized. Next slide please. Main thing, practical scenario is, we use a single droplet. You will be getting around 2 watts of power. What if we use multiple droplets like this? So we can harness more amount of energy. It comes up to around 20 watts of power. And one more thing is, using DC-DC boosters, we can boost the voltage up till 75 volts. This is being researched in this electrowetting field. Next please. Yeah, that's what I said. 35 watt of power, 35 voltage of power for 2 watt biasing, and 10 watts of bias power is recorded for 75. It's boosted up to 75 volts. This is how the coiling goes. There are two pouches with this microfluidic film. As soon as you press it, it moves to the forward position, and then it gets charged. The capacitor charge, and thus it can be used for charging the battery. When you press the front pouch, it goes back in the other way around. So for one footstep, you can record two different movements. Next please. Circuit diagram is very simple. The reward unit is nothing but a variable capacitor. We need to attach a load, and then the bias voltage, which is nothing but the battery, which stores as well as gives 3.7 volts. Next please. Next. This is the prototype. The front pouch, back pouch and front pouch. Within in the middle we have this battery unit with charges. Next please. Energy efficiency and optimization. One thing is, the microfluidic which we use is very important. We need to have very high dielectric constant and very high dielectric breakdown, which is seen only in this liquid metals. And the most suited one is tantalum pentoxide, Ta2O5. It's like it has a dielectric constant of 25, so dielectric breakdown is pretty high. Next comes, and charge clogging is one more thing which we have to concentrate on. To minimize this, we have to use fluoropolymers. I mean, the CyTop is the best fluoropolymer which is used. Using nanotechnology processes, we created a compound of CyTop as well as this Ta2O5, so that we got perfect microfluidic, which gives very high efficiency for a given DC bias voltage as well as for a given pressure. Next please. Okay, this is the piezoelectric crystal which I was talking about. Disadvantages I have mentioned previously. Next one. And mechanical, difficulty, worn out parts, wearing out is one thing. Life cycle is very limited, and size of shoes become very large. I mean, you can feel the weight of that module. Gear is very heavy, so you can feel the gait as the person is walking. Next one. One thing is versatility, which is a very important factor. Efficiency is also very important, and compactness. It is very compact, and it has practically infinite lifetime. In the case of spring, it gets off, whereas in fluid, nothing, no loss at all. Surface tension, it retains it. Next please. Future scope. One thing is you can use this as a device where you can carry to some, say you are hiking, you are going on a trip to forest. You don't have any electricity portals over there. The only choice, walk for 10 kilometers, battery gets charged, and just plug it in, use the mobile. That's the concept how it goes. And even you can use this in marine cave. I mean, mariners can use this. Cavemen can use it. And then battery charging is the main important part. Then next please. Tire you can use it. We are done with it. This is the conclusion. Okay, within the tire you can embed this module and then you can use it. Next please. Hanging bridges, escalators, escalators, humps you can use it. These are the potential areas where you can harness large amount of energy, and even your footsteps. If each and every one has this module, you can charge your battery daily. Just walk and it gets charged. I mean, it's a marvel. Instead of just using this electricity concept, why can't we switch over to this technology? These are the references. And time for questions. Sir, it's a joint venture between both shoe companies as well as this technology. If we want to get the advantage of one, we have to have a tie. It's just like MVIT in MOU with some other university. So
both are education.
Yeah, both are education. So both are concerned with comforting as well as effective utilization of technology.
Other than tracking on the back of mobile phones,
it can be used in, as I said, humps and all. If you embed this in humps, road humps, it gets charged, battery unit. Basically what we are concentrating on is charging the battery and using the same one. The weight can be infinite. 40 watts of power are getting wasted for one footstep. Imagine how much can each and every one harness.
What you said initially is there is a piezoelectric lattice, there is more filter, significant timing, significant timing of 10,000 cycles. With respect to the droplets, what is the, after 10,000 cycles, the droplet may evaporate, may not exist at all.
Sir, so the thing is that we have used the particular compound only because the dielectric constant is more. So for that reason, even if we apply a lot of pressure, it won't break down.
It will not break down. It's a droplet, so it is a liquid, it may evaporate or not.
No, so we're providing the insulation over there. We are providing the insulation above that so that it doesn't evaporate. It's a non-volatile liquid basically.
so basically anything is there, there is always degradation in there. Like petrol evaporation is there, air in a VD leaks.
Right.
It will not remain same.
But the efficiency is
Maybe
really
it's
high.
slow. It's slow for a longer period of time. Here we will see
Right. And it's been practically implemented in China already. Like the walls are all under the the flooring of the walls has already been implemented.
So it's practically working already. So we have implemented this in shoes. We have taken the technology and implemented this in shoes.
Also, in the future, so you may see many people walking. So everyone catches a bus, or you may go in a taxi. So by walking, you get electricity. So you can revolutionize the whole world.
What is your main job? To reach a destination or trying to reach that?
So both what will happen? You can reach the destination at the same time you can charge the battery. So and one of the embedded types also.
Anyways, the doctors order the morning to go for a jog. So while jogging, it gets charged.
That's a good idea.
Thank you so much.
Thank you, Chimayati. The next paper is on the myth of virtual reality is more real now by Avita, Sankaleka and Chadha.
Good afternoon, one and all. My name is Avita and my teammate here is Chandralekha. We are here to present the topic, the myth of virtual reality.
Just go back to the previous slide. We note down the arguments.
So we are here to present the myth of virtual reality is more real now.
Yeah, move on.
Okay, so here we're going to cover the introduction, the historical background and the different types of virtual reality over the years, and the VR technology and the hardware required to implement such technology, and the 7 virtual realities that actually work in real life, and the advantages and disadvantages of virtual reality and the future, what we can expect, and we'll end it with a conclusion. So introduction, there's no universal definition. Many people have been able to explain it in many ways, but here is the definition. It's basically an illusionary environment created by a computer to give users a perception of reality, and then they believe that they are the reality itself. And the term was coined by Jared Mayer in 1987. And to enter such an environment, you need special equipment like cloud phones, joysticks, helmets, etc. And here is the model, a generic model. Historical background. So, 1961, Morton Angel patented Sensorama, a filmmaker, which is a virtual, mechanical virtual reality system, and then the head-mounted displays came into existence in 1965, and then you have the lunar mission simulators, and then VML, the virtual programming language company, manufactured data clouds and the iPhones in 1988. And the movie Matrix in 1999 is an example of virtual reality. So the virtual reality can be differentiated on many forms and many schemes. One of the schemes that's given here is given 7 types of virtual reality models. Among these, the immersive first-person environment is first-person experience where a person subjected to such an environment feels like, is subjected into the image. They can process everything within the environment. It's a direct contact with the virtual environment, and augmented reality is adding more to the generated virtual reality, and it finds extensive application. And then the mirror world is a second-person interface with the virtual reality system. The chamber and the wonder world is used in animation movies and 3D movies where the person wears a costume with sensors and every action is converted into animation. And then we have the chamber world, which is nothing but cave, where you have a room with walls and projections where the person can feel the virtual reality presence. And CAD simulated environments are used in science application with Polus interface, vibrators and stuff like that. And then cyberspace is also a term that can be used in order to deal with the virtual reality technology. It's an artificial reality that can be visited simultaneously by many people via network computers, and telepresence and teleportation is the feeling of being in a location other than where you are. And VR technology. Here, the picture depicts the human-computer-human interaction loop that is fundamental to any immersive system. Okay, so to enter such a system, like I said previously, the user needs equipment to enter such a system. One of the input devices is the data cloud. The data cloud is a sensor basically which can measure the movement of your hand, and then you have a polymer sensor which is attached to the back, which can measure the orientation of your hand. And then this is another input device, the 3D mouse, which can it emits ultrasound signals from each of the three transistors, which can receive the position, orientation, and the movement, and it provides proportional output in all the 6 degrees of freedom as shown. And then you have these are motion trackers, which have magnetic sensors, and they measure the magnetic field generated by the motion of the different segmented sensors. And then the output devices, they had mounted display. So it's an optical system that channels the images from the screens to the eye and thus presents a stereo view of the virtual world. And then you have the BOOM, which stands for binocular only oriented monitor. And it is a small box with two CRT screens. And the user can look into the box through two holes and observes and visualizes the virtual world, and he could guide through the arm as shown there. And then CAVE is Cave Automated Virtual Environment, which was created in 1992. And here you need stereo glasses and head tracking to enter such an environment. And then you have the haptical interface and tactical feedback for VE environments, like virtual environment. Here, the cybergraphs and stuff like that, these tools help you actually touch the 3D computer generated world and make it feel more real. Yes, these are the other output devices. And virtual reality modeling language is like HTML. And here you can see it's an excellent tool for modeling and 3-dimensional worlds that are functional and interactive. Now, more to the applications of virtual reality. There are 7 virtual reality techniques that actually work. Firstly, we have anxiety testing. It's in a wide use since a very long time. Like psychologists use it to get rid of the phobias and post-traumatic disorders, but this is done by exposing the person to the situation many times so that they get rid of the fear. Then multiplier online gaming. This here virtual world is created, which is the replica of the real world. Then World Warcraft is the largest gaming world in use now. And then the Nintendo Wii, it uses a different move to using the virtual reality world. It uses sensors in place of the typical heavy shoes they use. Medical procedures. Virtual reality has been extensive use in medical procedures. Like the students can have a very good look at the section of the body and the organs, and they can clear out the tissues, muscles, and have clear look at the organs. And one key advantage is that this can be repeated as many number of times as they want. And then Project Native is a recent introduction to the virtual world, where this uses voice and motion sensors instead of using controllers and keyboards. The cave is a virtual world where it has many walls, many projectors in it. This is used for scientific visualizations and creating 3D objects. And then virtual reality training programs have been used in Air Force flying, and then military applications, as I told before. The many advantages of virtual reality, like training, history, experience things which you wouldn't be able to experience in telescreen applications, which I'll explain later. Disadvantages are addiction and difficulty of distinguishing, and positive impacts on real world. Future of virtual reality. There are many researchers in this field, like some of them are utility for
cloud, which is used for 3D representations. To be or not to be, as we all know, physical body is prone to many limitations. As we age, our body dies and we weaken. But the brain contains a lot of information. But by using nanotechnology, the information can be preserved. We can choose. There is a option to choose if we want to actually live in a real world or a computer simulated world. Vertebra, as you see a few things here, this taps the brain from the biological body. Then electronic transference, this is mind uploading. The information in the brain can be transferred to the computer and stored. Telepresence. Telepresence is the concept of a person being able to visualize himself in a different location apart from his home location. This uses sensors which stimulate him, in which he can feel he is in a different location than where he is. Have you seen what virtual reality is? Even though there are disadvantages, like you might as well disengage yourself from the reality, but it has a lot of advantages to free phobias and to contribute to the lives of the disabled. And as the technology is growing rapidly, we can expect cheaper products, and so we can use it as a source of entertainment in platforms. Thank you.
The aim
team of this project was funded by the Mind and the Brain Institute of IFFC in Switzerland along with the IBM. The project was headed by the director Henry Markram. Next slide please. Now what exactly is a blue brain? Now blue brain is an artificial brain. It is not a natural brain, but it works similar to a natural brain. Like it can work on, it can think like a brain, it can proceed how the brain works. It can take decisions based upon the past experiences as a natural brain can. Next please. Why do we use a blue brain? Basically, there are 3 points why we use a blue brain. Blue brain can be a virtual brain, which is an exponential tool giving a neuroscientist a new understanding of a brain and a better understanding for neurological diseases. Now, since brain has always been a complex study, we cannot study a brain so much. So, we can use a blue brain to study a brain in more details. Thirdly, the intelligent brain can be lost when a human body dies. So we can control, blue brain can be used to gain everything back from which is the content of the brain. Now how it is possible? The researchers are involved studying slicing the living tissue using microprocessor and patch clamp electrodes. The data is used to build biologically realistic models of neurons and networks of neurons to create a grapple cortex. The simulation is carried out in a 2-gene supercomputer which is built by IBM, hence the name given blueprint. The stepping stones of a blueprint. They are basically
the first stepping stone is the data acquisition. The data acquisition, as the word states, is about how we collect the data and how we are going to implement the blueprint. The first point is that it involves taking the brain slices and placing them under a microscope and seeing the shape and the electrical activity of the individual neurons. The neurons are typed according to morphology, that is their shape, electrophysiological behavior, location within the cortex and the population density. These observations are translated into mathematical algorithms in order to define the form, shape and the location of the neurons which are inside the cerebral cortex. The cerebral cortex is the main important part of the brain which does the thinking and stores all the information. Next is the slicing is stayed with biosighting and viewed through a bright field microscope. See, when we stain it through biosighting, the difficulty is that it reduces the shape and the details of the neurons, but it can be gained with using the microscopes. The next is the electrophysiological behavior of neurons is studied using 12 patch plug instrument, and the Namarsky microscope enhances the contrast of the unstained samples of living neural tissues, and carbon nanotube coated electrodes can be used to improve the recording. The next slide. Simulation. The next step is the simulation. In the simulation stage, we use the software package that is called Neuron. The Neuron, this was developed by Michael Hines of Yale University, and it is written in C, C++ or Fortran language. It can be written in any of the languages. The simulation steps involve synthesizing the virtual brain according to the algorithms. The algorithms which we prepared in the data acquisition stage can be used in order to create the neurons based on those algorithms. Every single protein is stimulated and there are about billion of these in one cell. Finally, the neurons are functionalized and stimulated and brought to life. And the latest simulation as of November 2011 contains 100 columns, 1 million neurons and 7 billion synapses. The synapses are those electrical activities which is generated in the neurons. And every 2 weeks a column model is done. The simulation reproduces observations that are seen in the living neurons. Now the third and the last step is the visualization of the result. Visualization of the result. The RT neuron is the software which is used to create the 3D view of the neurons which is created in the simulation stage. And it is written in C++ and OpenGL. It is used C++ and OpenGL
the software. RT neuron takes the output from the simulation of the neuron and renders them in 3D. The animations can be stopped, started and zoomed, thus letting the researchers interact with the model. How it is zoomed, how we can see the activities which are happening inside the brain, it can be done using them. Now these are the instruments which are used. First is 3D neuron morphology reconstructions, means how the algorithms are used and how the neurons are designed. Is the neuron cell window, that is the neuron software which is designing the neurons. The next is the 3D neuron morphology construction. The 3D construction is done. Then patch trap electrodes are there which are used to study the brain cell tissues, the slices of brain cell tissues. And the third is RT neuron visualization, which shows the 3D view how the electric signals are generated, how the synapses work in neurons. Next thing. Now hardware requirement. The first one is the Blue Gene supercomputer. Blue Gene supercomputer primary machine uses the Blue Brain project built by IBM. This project is done in collaboration with IBM and it is guided under the director Marcon, who is the professor at Lausanne University in Lausanne in Switzerland. Next one is silicon graphics, a 32-bit processor silicon graphics system for commodity PC cluster. Clusters of commodity PCs having been used for visualizing tasks and RT neuron 11 node cluster at 24 GB RAM NVIDIA GeForce graphics card. Advantages. The main advantage is the brain disease risk. In the future, we are it is estimated that the human can suffer from 560 different brain diseases. Now, the solution for that can be a blue brain. A blue brain can be used for the brain disease treatment for better and faster treatment of the brain diseases. Next is scientific curiosity about consciousness and the human mind. You can have a detailed study about the human mind, integration of all neuroscientific research worldwide, progress towards building thinking machines, and the project is becoming a brain simulation facility that is accessible to all. It can be used to connect all the neurologists around the whole world and they can do research on this. Next is disadvantages. We become dependent on computers. It is fully dependent on computers. It is very costly. The project is very costly and others can use technical knowledge against us. And the conclusion is that Blue Brain is a resounding source and in 5 years work, NV Market team has perfected a facility that can create realistic model of one brain, essential building blocks. Till now, simulation of honeybee brain has been done, which includes 100 vertical columns. And now by 2014, rat brain can be simulated, which has 1 billion neurons and 1 billion synapses. And by 2023, the human brain will be simulated, which has 86 billion neurons.
Data analysis. It involves taking the brain slices, placing them on the and basically are you going to use the data brain slice how do you take this brain slice? Why the name blue? Blue brain? Blue brain because the blue gene supercomputer which was developed by IBM is used to carry out research. So
can do it on that.
The correlation between artificial and then the real one.
Yes, we can identify the
Essays in that. You can only feel what I identifying the disease.
based on like we are not taking a single data, we are taking their research on every type of a disease, pain, everything. Yeah, everything.
If you want to take one disease, you have to take that particular person's age who is having that disease. Then you hit that only, right? You are particularly taking the disease brain and what
How do you identify that?
We are taking a lack of things,
Okay.
Might be possible. Okay, good. Thank you.
Currently, there is fixed time interval for red and green lights. This causes reinforcement learning as proposed by Ford. In this system, the waiting time is determined by the neural network. The disadvantage of the system is that there are large number of states. Prediction-based optimization is proposed by Papyrus and Marconi. In this system, the measurements of the current cycle is used to determine the time of the next session. But the disadvantage of the system is that the data is taken only from one cycle, so it doesn't control the traffic very effectively. Using magnetoresistive sensors like Gen, in the system, the sensors use wireless traffic information and the sensors are located on the road, but the disadvantage is that the maintenance cost is very high. Proposed system. Proposed system is to, the main objective of our proposed system is to reduce the problems of traffic congestion. First objective is to calculate the density of the vehicles on the road. And the second objective is to have priority-based signaling to have a priority for emergency vehicles. The IR sensors are mounted on the road, and the output of the IR sensor is given to the smart traffic control system, and this output is given as signals to the traffic lights. And priority can be given to emergency vehicles, wherein the lane in which the emergency vehicle is passing, the traffic light is made green, all the lanes the traffic light is made red. And if a driver wants information about the traffic congestion, then he can send an SMS on the GSM mobile interface, wherein he can get information about the traffic congestion and also the OTS. This graph shows that as the traffic density increases, the green time also increases linearly. As the traffic density increases, the time in which the green light is on also increases, and it also vice versa.
These are the components of our proposed system. Firstly, it's the microcontroller. This stores the count of number of vehicles on the road, and this uses this count to update the traffic light details. Secondly, these are the sensors. The sensors give measurable response to change in physical condition. The most commonly used sensors can be ultrasonic sensors or infrared sensors. A mode, or it's also known as a sensor node. It is a part of wireless sensor network. It is capable of performing the processing required, gathering sensory information and communicating with other sensors. Next is communication through GSM mobile interface. This is possible with the help of the STC system having GSM mobile interface, and we design an application which includes the address of each STC system and its corresponding unique ID. If the driver wants to know about the traffic status at any particular junction, he can use this app. He should just specify the address of a particular junction and he can get the unique ID corresponding to it. And with that ID, he can send an SMS, and this STC system responds to his request by sending the particular status at that time and available alternate routes if there's a lot of traffic jam using GPS technology.
This system shows the block diagram of STC system. Here, the output of the IR sensor is given to the computer system, and the timing information is calculated based on programming, and this timing information can be given to the traffic signals using the control unit. The embedded system is in the control unit, and here parallel communication interface APIs are used, and the time in which the traffic light is on is depends on the density of the vehicle. And in case of any power supply failure, then battery backups are provided. But if the battery backup failure also occurs, then the traffic control is taken over manually by informing the authorities. Okay, this is a real-time scenario, and you can consider three junctions A, B, and C. You can see that sensors are located at each junction, and the traffic density at junction A is very high. So, as we discussed earlier, the driver can be informed through an SMS on the GSM mobile interface that the density is high, so the alternate route, that is route 1, can be taken at junction C. If an emergency vehicle such as ambulance has to pass to the route AB, then the traffic signals at the lanes crossing these routes are made red, but only the emergency vehicle can pass to the route AB.
This is mainly for ambulance detection. We make use of sound sensors such as microphone. The microphone, when it receives a sound signal from the siren, from any authorized ambulance, police vehicle, etc., it converts it into equivalent electronic signal and gives it to the STC system through microphone interface card. This STC unit performs the processing and it glows the light accordingly. We also have visual verification light to avoid misutilization of this feature by normal police. So the two major objectives such as calculating the density of vehicles on the road to smooth the flow of traffic and priority-based signaling are studied successfully. When this system is implemented properly, we have many benefits such as less fuel consumption and less pollution. The system mainly aims at reducing a large amount of waiting time caused due to traffic problems and accidents.
directly.
Mode is actually weightless sensor. Okay, it has got a processor, it has got a sensor, everything. That is complete thing is referred as a normal mode. In that mode, you will not subscribe the sensor again. They different is mode means it has got a sensor as well as a processor. It transmits this very
Study of nanowire superconducting magnetic energy storage system in association with supercapacitor by Anita and MVIT of third year electronics. Without any significant power losses. SMES, superconducting magnetic energy storage system, is one of the energy storage systems. It is a novel technology. It is one of the novel technology to store the electricity from the grid of the magnetic coil without any significant power losses in accordance with the superconducting material. The main objective of this is to suggest a hybrid energy storage system for the present energy storage system, to study the use of nanowire with the superconducting magnetic energy storage system. Practical and theoretical analysis of these nanowire superconducting energy storage system is necessary. Combining the supercapacitor with these SMES will store the electricity efficiently without any significant power losses. The quality of the power is increased. Superconducting magnetic energy storage system is a novel technology that stores the electricity in the magnetic field of a superconducting coil with no zero loss of energy. The combination of the three fundamental principles, the zero loss of energy, the electric magnetic field, and the energy storage in magnetic field, provides the potential for the high efficient storage of the electric energy in a superconducting coil. But the existing SMES has two major disadvantages. As current is passed through a superconductor, the superconductor is destroyed by the created magnetic field before efficient value of the utilization is reached. And we need expensive refrigeration units and high power cost to maintain the operating temperature. These problems of the superconducting application may get improved by using a nanotechnology in the performance of superconducting materials in the SMES. The typical SMES consists of the two parts. It consists of the two parts, the cryogenic unit and the storage system. Here, we take out the
do is we use a cryogenic refrigerator and we use nitrogen as a coolant, which can act as a coolant up to till 4.2 kilo, 42 kilo temperature. And this magnet and the coolant are contained in a thermally insulated container called a cryostat. To keep the helium from boiling away, the cryostat is usually constructed with a rounder jacket containing liquid nitrogenous oxide. But the overall essence is this. But overall, this thing is have less storage of electricity. For this, we use a capacitor in hybrid with this SMES system. The supercapacitor have a different electric storage system. In the supercapacitor, the energy is stored electrostatically at the surface of the material and does not involve chemical reaction given the electric mechanism. And it leads to charges quickly and leading to a very high power density. So do not lose the storage capacity over time. This SMES unit is environment friendly because it doesn't involve any chemical reactions like in addition like acids, toxins, etc. as it is in batteries. We are connecting photovoltaic energy systems to the SMES instead of connecting to the battery energy storage systems in association with the supercapacitor for holding the efficient amount of energy without any significant power losses. The outcome of this research will definitely ensure that the efficiency of the electricity is improved without any significant power losses. It is more applicable than the power plants.
Whatever taken is good. Right.
So what number? 9 and
10, sir. Study of nanowire superconducting metal resource system in
5G denotes the next major phase of mobile telecommunication standard, and it is expected to be released in 2020. The ultimate goal of 5G is to design a complete wireless world that is free from obstacles like slow internet speed, more cost, more energy consumption and all that. If 5G appears, then it will support features like increased bit rates, higher number of simultaneously connected devices, lower battery consumption, better coverage, higher number of supported devices, etc. This we can connect more number of devices simultaneously. And 5G is seen as a user-centric concept instead of operator-centric as in 3G and service-centric as in 4G. Like in 5G, that applications to be developed with concern with the users. And starting from 1970, after every decade, one generation is evolved. Like first generation was evolved after late 1980 and early 1990. It was based on analog system and allow user to make voice call only, and only in one country. Like you cannot make call in other countries. Then 2G was evolved in late 1990s, and it provided services such as digital voice and SMS with more clarity and semi-global facilities. Then 3G evolved within 1990 and 2000. It leaves a transmission speed from 125 kbps to 2 Mbps, superior voice quality, good clarity in voice conference and global roaming. Then 4G evolved, and in 2010 it was faster and more reliable and gives speed up to 100 Mbps. It provides both cellular and broadband multimedia services everywhere. Then we are expecting 5G, that is 5th generation, and it will have 10 times more capacity than others. Its expected speed is up to 1 Gbps, and it will be more faster and reliable than 4G. Then I compare all the generations based on some criteria like deployment, bandwidth, technology, services, multiplexing, switching, core network and type. 1G was deployed in 1970 to 1984, 2G and 2.5G, along with 2.7G it was deployed in 1980 to 1999, like that, and 5G is expected up to 2015. Then bandwidth of 1G was 2 kbps, 2.5, 2.7 and 2G was 40 to 64 kbps, bandwidth of 3G is 2 Mbps, bandwidth of 4G is 200 Mbps and 5G is 1 Gbps. Technology used in 1G is analog cellular, then 2G, 2.5G and 2.7G it is digital cellular, then 3G it is broad bandwidth, CDMA and IP technology, that is 4 division multiple access and internet protocol technology. For 4G it is unified IP and seamless combo of LAN, WAN, WLAN and PAN. For 5G it is 4G plus WWWW, that is wireless world wide web. Services provided by 1G was only mobile telephony. For services provided by 2G, 2.5G and 2.7G was digital voice and short messaging. By 3G was integrated high quality audio, video and data. By 4G it is dynamic information access and variable devices. But services provided by 5G will be dynamic information access, variable devices with AI capability, that is artificial intelligence capabilities. Multiplexing used in 1G it was FDMA, that is frequency division multiple access. In 2G, 2.5G and 2.7G it was CDMA and CDMA, that is time division multiple access and 4 division multiple access. In 3G it is CDMA, 4G and 5G it is CDMA. Switching used in 1G was circuit switching. In 2G, 2.5G and 2.7G it was circuit, and for 3G it was packet except for AI interface, and 4G and 5G it is all packet. Then core network it is PSTN, packet network and internet, and hands-off is horizontal and vertical. Now I will discuss about that why we need the 5G. Instead we have the 4G already. Then why we require what are the future requirements of the 5G. And then I will discuss about what are the technologies and concepts that we can use in the 5G technology. by using our limited radio frequencies. It is expected that the video data traffic will increase by 1,000-fold by 2020, and there will be 50 billion and more electronic devices. So we require the 5G technology to cope up with this problem. Then I will discuss about the 5G technologies and the concepts that we can use. There are many new technologies and techniques that we can use in the 5G technology, but this all our technology are being developed, but its standards have not yet been defined. The first technology that we can use is pervasive networks. Pervasive network is the ability for devices to autonomously arrange themselves into local networks and exchange information through these networks. It is the idea that many devices from appliances to cars to everything will be embedded with a chip that will be connected to the infinite network of other devices. And the exchange of information will be easy. The next technology we can use is through cooperative relays. In this technique is concerned with the maximizing the network channel capacities for any given bandwidth. It will exploit the user diversity by using the relay signal and direct signal in wireless multi of networks. Next technology is cognitive radio technology. It would enable the user equipment to look at the radio landscape and in which it is located and choose the optimum radio access network. The next technology is wireless mesh networking and dynamic ad hoc network. It is a decentralized type of network, and it is called as ad hoc because it does not rely on the pre-existing infrastructures like routers and access points. Here the nodes will participate in routing by forwarding the data to other nodes. So the determination that which node will forward the data is done dynamically. The next technology we can use is atomic support. This will increase the address size from 32 bits to 128 bits, and it will support the more levels of hierarchy of addressing. Next is cloud computing. In this technology, we can maintain the applications and data in an internet and the remote server. And the user and business can use the application without any installation, and they can access their personal files with the help of their any network by using internet. 5G technology is going to be a new revolution in wireless system market. The term 5G is not officially used for any particular specification or any official document made public by the telecommunication companies.
the role of the heart. With the increasing craze of mobile phones, we often see a wave of confusion, which phone to buy and which not to buy. Every company wants to provide best features and have competition day by day. I guess everyone has a smartphone, right? But do you know the versions, the architecture, the OS which is better, and the features in what manner? All this revolves around one thing, that is mobile operating system. So here we come up with all the queries popping in our mind. What is mobile operating system? Mobile operating system refers to as mobile OS that operates a smartphone, table, tablet or other mobile devices. It includes the features like GPS navigation, Bluetooth, camera, etc. GPS navigation, for example, if we are attending someone's marriage and we are stuck on some lane, so with the help of GPS navigation, we can attend in time, right? It gives the platform so that developers can create their own apps. And now we'll discuss about the Android, the major versions of Android. First of all, what is Android? Android is another operating system which is from Google Inc. It's an open source. Hearing this open source, it comes in mind. What is open source? It acts as unlocked hardware to develop any user according to our wish. The versions are nicknamed after streets or deserts. It sounds yummy, right? The first version is Cupcake. It supports widgets. Next. It supports widgets, video recording, ability to upload videos on YouTube and Picasa. Right now, whatever seminar we are giving, it will be uploaded on videos, uploaded on YouTube, right guys? The second one is Donut. Fix reboot errors, revamp camera interface and better search engines. 2.0, 2.21 is Eclairs. It revamped the user interface, it introduced HTML5 and it also improved the Google Maps. The next one is 2.2 Froyo. It added Wi-Fi hotspot tethering, auto flash support. 2.3 Gingerbread. Improved the soft keyboard, copy and paste features were available. Honeycomb 3.0. It supports holographic user interface like 3D on all, barcode on all we use it. Video chat via Google Talk. It's very easy to talk whoever is far. 4.0 Ice Cream Sandwich. Access apps directly from lock screen. Supports Wi-Fi directly. And it's also a combination of gingerbread and honeycomb. 4.1, 4.2, 4.3 are the versions of Jelly Bean, which was recent. Lock screen improvements were there, Bluetooth gamepads and joysticks. And the latest version is 4.4 KitKat. It has the ability to use immersive mode, that is to keep status and navigation bar hidden. This is the Android evolution. The first Cupcake, Donut, Eclairs, Froyo, Gingerbread, Honeycomb, Ice Cream, Jelly Bean and the last one is KitKat. All with the alphabetical orders. The architecture, it's based on Linux kernel. It includes the libraries, debuggers, handset emulators, documentation, sample code, tutorials. And the apps like Candy Crush for games, everyone is playing, Cut the Rope, Free SMS, Hike, etc. iOS is from Apple Incorporated. This OS was released on 2007. The user interface is based on the concept of direct manipulation using multi-touch gesture. Interface control elements consist of sliders, switches, and buttons. iOS is used in Apple products like iPhone
CDMA, code division multiple access, copy paste, fast application startup, and in this Windows Phone 7.5, which includes messaging and social integration. 7.8, that has improved the lock screen and enables tethering Wi-Fi. Windows Phone 8 supports multi-core CPUs up to 64 cores and 1080 pixels of screen resolution. Internet Explorer 10 has improved the internet sharing. Windows Phone 8.1, which revamped the user interface, supports the new technology, and Internet Explorer 11. Architecture. In this, most important Windows Phone frameworks are Silverlight and XNA framework because it encapsulates the several important and essential fundamental applications. As we have discussed about the Android and iOS, now we discuss with the BlackBerry. BlackBerry is also an operating system, and it was developed by RIM, Research in Motion. It was released in 1999, and the founder was Mike Lazaridis. The OS is designed in C++ language. It supports Java language also. OS provides the multitasking and supports specialized input devices such as touchscreen, trackball, and touch wheel. The versions 1.0, it was released in 1999 for the mobile system Pager BlackBerry 580. The another was 3.6, which was released in August 2008 for BlackBerry Bold. 6.0 was released after 2 years, which include WebKit-based browsers. 7.0 was released in 2011. Any smartphone running on earlier version couldn't update to this version. Nowadays, update is very important. But 7.1, it was released in 2012 and it overcome that disadvantage. Now 7.0, it has updated the version 7.0. It has got added features, for example, Wi-Fi hotspot, listening to FM radios, example, etc. The architecture, it's based on Linux OS, and the main important is UI System Manager. It provides the features like navigations, local and web searches. Web searches is very important. Right now the presentation is also due to the web searches. Now the competition is everywhere. So in mobile OS there is war between various OSs. Like there are so many features like control center, notification center, multitasking preview, in which we can differentiate between everyone. Like automatic app updates. So in the Apple devices you can automatically upgrade the background, while in Android you can't update it. User can select option while downloading them. In Windows Phone 8, yes, it will be updated, and in BlackBerry users can upload one by one, not simultaneously. Password protected reset, in car integration it will use, like in password protected reset, if your phone is stolen and it is of iOS 7, then you can't be using because it has to provide the owner's Apple ID and password. Without it, it won't work. In Android, there is no such provision, and in Windows Phone 8 and BlackBerry also there is no such provision. Conclusion is developers like us. OS is a platform where we can develop it innovatively with new what are coming. It's lacking. Thank you.
The next topic is PMITT by Sanjay Sharma, Jyotsna and Shradha.
Good morning everyone. We are here to talk about the Global Mobility Support Protocol PMIP-V6. Proxy Mobile IPv6. Proxy. In this presentation, we'll discuss the introduction, background, the comparison between the V4 version and the V6 version, how it works in the current trends and individual configurations. Proxy Mobile IPv6 is a network-based mobility management protocol standardized by the Internet Engineering Task Force. It is a protocol for building a common access technology independent of mobile core networks. It is one of the protocols to enhance the mobility management in the mobile IP. With PMIP, we can change the point of attachment of the host to the Internet without changing its IP address. This functionality is done by the network, which is responsible for tracking the movement of the host and initiating the required mobility signaling on its behalf. We have used some of the terminologies in this paper. Some of these are proxy mobile IP V6 domain. It refers to the network where the mobility management of a mobile node is handled using the PMIP V6 protocol. Mobile node is device that connects through a wireless network to the local mobility domain. Corresponding node is the node which wants to communicate with the mobile node in the Internet or also in the local mobility domain. Local mobility anchor is the home agent for the mobile node in the PMIP V6 domain. Mobile access gateway performs the mobility related signaling on behalf of the mobile node. As we see how it has evolved, IP was the connection-less datagram service in the original transmission control protocol introduced in the year of 1974. Internet protocol was designed initially to support communication between fixed endpoints. Then came an era for the portable devices. The portable devices needs to improve on the disruption of services. This gave birth to the PMIP V4 and later on to PMIP V6. PMIP V6 came into play when the mobile node wants to be communicating with others. In PMIP V6, when the mobile node enters a new network, then it knows about the existence of the router through the router advertisement messages. While PM enters a new network, it performs address reconfiguration to get its temporary care of address. The binding update, which contains the care of address and the home address, may be sent to all the corresponding nodes that is communicating with the mobile node. When home agent receives this binding update messages, it updates its cache table with a combination of care of address and the home address. There are two ways of communication between the mobile node and the corresponding node. As you can see in the diagram, the one way is bidirectional mode. In bidirectional mode, when CM wants to communicate with the MN, it first sends the packet to the home agent of mobile node that will route it to the MN's care of address. In route optimization, the CN contains a binding cache that has a combination of MS care of address and the home address. Using this combination, the CN can directly route the packet to the MS care of address without avoiding a longer path. As we can compare all this on the basis of there are basis of criteria on which we can compare all the versions which has come into existence. The criteria can be mobility scope, location management, required infrastructure, mobile node modification, handover latency, and the localized routing. Now my friend. As our friend just talked about MIPv6, I want to tell you first why we need PVC. In MIPv6, we have to go through the home agent whenever we want to communicate with communication between the CN and the MN. But this can be there can be a situation when CN and MN are very close to one another, but because we are going through the home agent, it is taking a longer time and it is wasting a lot of resources in the network. In that case, we come into PMRv6, in which there is a domain. There is a domain in which there are a lot of networks. Until the time the MN is within the network, we can have the same IP address and we can have communicated. When it is within the network, we can have a LMA and which will communicate with the rest of the environment. It need not worry about the home agent at all. LMA acts as a home agent in this situation. We'll see how it works. We have MN. As soon as the MN enters the domain, the MAC knows that there is a new device into the system, and it tries to authenticate the MN by seeing the MN ID acquired by it, and it checks all the details, and it checks if it is possible to connect that into the domain. If it is possible, the MN has sent the router a solicitation message to know that what are all the MACs available and which is the nearest most MAC. As soon as it finds the nearest most MAC, the MAC gets a proxy binding update message and it takes the MN ID of the MN along with its own ID and sends it to the LMN. As soon as the anchor gets it, the anchor tries to check it with its own entry which has saved it within its own memory, that is the device already present in the list. If it's not present in the list, it will give it a new home agent prefix and it will send back the proxy binding acknowledgement along with the prefix back to the MAC. And also it will create a bidirectional tunnel for communication between the MAC and LMA. As soon as the MAC receives the binding acknowledgement, it knows the prefix which it has to send back to the MN, and it gives that prefix back to the MN along with the router advertisement. That is when we want to communicate, when we have a new data entered into it. As soon as the MN is a domain, it has connected and it wants to move to another access point, another access point into that domain. What happens is the MAC detaches itself from the first MAC. As soon as the MAC notices that it has detached itself, MAC sends a registration signal to the LMA telling that the node has moved and I want it to be removed from the LMA list. As soon as it receives it, the LMA, when the proxy binding update is received by the LMA what it does is it sets out a timer because it wants to know that if the MN has moved into some other MAC, then that MAC will send again a proxy update to it, and it can just update the entries in the LMA instead of removing it and re-entering in the LMA list. So it waits for the timer until the time. What it does is if there is any data from the MN, that means that it has sent to LMA for transmission and everything is dropped, and the LMA waits for another MN to send a proxy binding update. By the time it sends back a proxy binding acknowledgement telling that okay fine, after some time I'll remove it from the list if you don't want it. If that is the case, if there is no other MN that comes into picture and tells that I want this MN to be registered, that entry is deleted from the LMA list, binding cache list. If there is another MAC, that is MAC 2, and it comes and it again tells it that there is a new node, the LMA what it does is it just updates the MAC number and
keeps the prefix same and again gives back the acknowledgement, and then it goes to the MN, and MN, there is no need for the MN to change its IP address to the new tech, and that is the advantage of the PMI IP visit. There is no handover delays because it need not change the IP address till the time it is in the same domain. The device will have an IP address and it will remain same throughout. That is, there is an efficiency because we have a handover delay. We want it to be removed. Handover delays can be because of new prefixes or because of we have to keep checking if there is a duplication of an IP address present in the domain. There are two ways to make it more efficient, that is predictive mode, in which before the handover takes place, the device MN tells that I am going to shift to another MAC. Please make a connection between the two MACs and please shift all the data, all my data which are present in the old MAC to the new MAC. It can be reactive mode also, in which that shift takes place from MN goes from MAC 1 to MAC 2, and then it can give its own data through itself, or it can ask them to take it from the old MAC. Then we have localized routing. In localized routing, if there is a constant connection between MN, there is two nodes, what we can do is we can have a temporary channel created between the two, so that there is no need for LMA to come into picture. We have, while concluding, I'll tell that proxy mobile overcomes the shortcoming of host-based mobility network protocols, and there is one disadvantage which needs to be overcome, is that there is point-to-point connection between the MAC and the nodes, which is very bad if there are a lot of nodes in the domain and it wants to all of the MACs to be connected to the same thing. So we have, that's the future hope for it.
have textual password and graphical password, and tokens such as ATM cards, ID cards, and smart cards. And in biometrics, we give up to the physical body itself as a password. So, moving on to first textual password. Textual password is a alphanumerical password. Most we use textual password all over. For example, we use it in Facebook and in Gmail, etc. There are two kinds in this. One is recall-based technique to repeat a secret that was used by the user before. Whatever the has typed before it, the password, it is recalled again when he comes to log in next time. One more is recognition-based. The recognition-based is the user should recognize which password she has selected before. Then we should choose a password in such a way that it should be easy to remember, but it is difficult to guess by the hackers. The key scientists stated that there are almost going to 10 to the power 4 possible passwords, which is easy to crack 25% graphical 25% of the password. Next, let's move on. The drawback of textual password is that it can be easily cracked. Next is graphical password. We use image for the graphical password. For example, an environment image, we can select food, people, society. We can locate each object in the image. The selection of the object constructs the password. The sequence in which we select the object is constructed as a password. So here recall and recognition of pictures is better than using the textual password. Image is better than textual password. It consumes less space compared to the textual password. The drawback of graphical password is it can be easily recorded or observed. When a person is trying to log in through this graphical password, the attackers can observe and record, and thus they can log in. This is the drawback of graphical password. Next, let's move on to biometrics. Biometrics, we give our physical body itself as a password. For example, fingerprints, face recognition, then voice, then our walking behavior, walking style, etc. can be given as a biometric password. Drawback of this password is few people can't harm their eyes by always rating them to subject to a low intensity infrared light. So this is a drawback. And one more drawback is the attackers can drawback of this is intrusiveness upon users' personal characteristics. So because of that, to overcome this drawbacks, we have 3D password. It is a multi-factor authentication system. Choosing authentication technique for 3D password. This 3D password is used in high-level security for high-level security purpose. 3D password is a combination of all three authentication. So it can be combination of graphical, textual, and biometrics. Here the password is there are so many we create a virtual environment, 3D virtual environment where we have so many objects and items. The password is constructed such a way that the user interacts with objects or the actions that we perform. Based on they observe what action and interaction that they have performed. The sequence of this action and interaction on the object present in the virtual 3D, the password is constructed. Here the advantage of 3D password is the user is given freedom to choose which kind of authentication system technique he needs. If he wants biometrics, he can use biometrics. If he wants texture, it's his wish whether which he has to use. I have to give an example for the 3D password. For example, we create a 3D virtual machine. There are so many objects in that, and there are some input devices which controls the 3D images or objects present in the computer virtual environment. We have the fingerprint scanner to scan our fingerprints, and we have mouse, keyboard user name, then we can type the username, then we can give a fingerprint as a biometric password, and then we can select the images object, and we can include the graphical authentication. Now, how the user interacts with the object. After entering the username, he'll pick out the pen from her. That is one action. From a place, he'll pick the pen. That is one action. That is recorded as a password. And one more, he'll place the book from one place to other. All this is going in a 3D virtual environment. So virtual environment is present in computer. So whatever we are performing, it is the password. So next time, if you perform this, next time you have to log in. That will be the same thing to log in. That sequence, same sequence you have to follow again when you have to log in. The actions can be replacing one from others and switching on the light on and off. Then stapler, stapling, all these are the actions for 3D password. It's in a virtual environment. These are the sequence in which way you have to go. Next time if you have to come to log in, you have to perform the same sequence which you have performed before. This is the example for the application of high level security purpose, we use 3D password. In ICS bank and in military services, airplanes and jet flights, we use these kind of this 3D password. Next is 3D virtual design. The virtual environment which we create should be similar, should reflect same as the real time. Suppose same thing should be repeated. It should be reflected to the real time. The object used in virtual environment should be related similar in size to object, and action interaction to a virtual object should reflect the real time situation. Next one, please.
When we talk about 3D password, the first question which comes into our mind is what 3D password actually contains. And it contains a 3D environment space of size G cross G cross G. And here the objects are represented in the form of coordinates, and each coordinate for the object is it differs from each other. So let me take an example. Here there are two rooms. One is office room and another one is a meeting room. A user enters from the office room to a meeting room. So he opens the door and he closes the door, and he finds that a computer is in left side, and he types A in it. For example, he types A in it, and then he picks up the pen and he put a point on a sheet of paper. So this is the example. So the location of the all objects is represented in the form of coordinates, as I said before. So this is the example for action and interaction of the user with the object in the 3D virtual environment space. Next. This is the first figure, shows the 3D virtual environment where a virtual computer is located. Here user can enter a textual password. So next, and he can log in into a system. So next one shows this is also 3D virtual environment space where there are 3 computers and 3 graphics. So it's up to the user which he wants to choose. Either he can choose textual also, or else he can choose graphical picture also. So first figure is representing the biometric password. Here user can give this one fingerprints, and next one is also combination of the both. This is a transition diagram where a black spot represents initial state. Here user can enter his name, and when he enters his name, he moves into a 3D virtual environment. Here, if a user has only textual password, so when he enters a password, it will be passed. Then it is sent for verification. If it is correct, then access is granted. Otherwise, he has to repeat the same thing for other passwords. If he chooses graphical, the same thing, and if he chooses biometric, that also same thing. And another state is when some object in the 3D virtual environment changes, it will be represented. So next one is
conclusion. So for a person, it's very difficult to crack the other one's password because it's a combination of all these things. So it's very difficult for other to predict what that person has chosen as his password. So it's used in ATMs also. It can be used, and it is used in my jet flights and aeroplanes. Thank you.
How do you give a 3D password? How do you give a 3D password? You should have a 3D signal first.
No, sir, it's like it's application once. We use laptops. We use laptop. If we have some file and we don't want.
See, what for this password is?
It's for high level security purposes because nowadays people
Not for them.
It's not for
The ATM always has a virtual environment.
not yet, sir. It can be used for capture.
You check on the statement. The password should be easier to remember, difficult to hack.
Protection password, not free password.
The combination of all these, it is much more complicated.
That's why we use 3D passwords, sir. We can't say it's not original.
Reading password is having a 3-dimension or 3-dimensional signal, or it is a combination of three different types of passwords.
Combination of the different passwords.
Is it biometric, textual, like that, picture?
In the application, if we enter username, so he enters into virtual environment laptop. So for a file we can use it. It is a very secret one. So for that.
So what was shown 3D virtual environment. How do you create a virtual environment?
For laptops, through the graphics, yes, computer graphics, through that.
It's a very good procedure for a high-level application. But still, you have to write out somewhere in your pocket and you open and see it and you there are limited access.
So servers which is where more information is stored there. That means brands for managers.
Since
Only for high level.
I detection is bad. You report this to our people management. Long term you will do
Password techniques now.
No, I did not definitely not change the application. So I computer never like it in the way you are going for graphical
That's what I
should not use it change you are going to use the actual long term.
whenever you have to log in, subject or your eyes,
If the user don't want them, if he doesn't have any
Good afternoon to everyone. I am here to talk about thin-film MOSFETs, myself Sunesh and D. Sridhar. First of all, why MOSFETs? MOSFETs came into picture due to the disadvantages of previously invented semiconductor devices. That is nothing but
bipolar junction transistor. What are all the disadvantages of bipolar junction transistor? Became the advantage in MOSFETs. First of all, bipolar junction transistor has very large area, so MOSFETs consumes very small area, and fabrication process is very easy in case of MOSFETs. And we have analog mixed signal, which is using both analog and digital functions. It will be used in FM. The history of MOSFETs. The person who invented MOSFET is Bernard and John Chunson. Thin film MOSFET is a dual gate thin film MOSFET device having a sufficiently thin body thickness or more semiconductor channel layers sandwiched by semiconductor layers having different energy band structure. As we can see from the bottom figure that we have two gates, top gate and a bottom gate. We have two channels of silicon, Si. In between we have sandwiched a silicon germanium. And the insulator layer which is used between top gate and silicon is silicon dioxide. The first figure depicts, it's like a cartoon, two people standing in front of volcano asking what to do with so much of silicon dioxide. Just simple, use it in MOSFETs. It depicts picture of a thin film MOSFET. We have two gates and drain and source between which we have formed a channel. Next. This also depicts the same, but it's electron microscope photograph. Next, going on to fabrication process. Let us imagine a rectangular silicon crystal cut wafer. First, we will take a gate layer deposited at that portion, above which we will deposit SiO2 layer, which is nothing but an insulator. Above which we will deposit a silicon and the alternate process, silicon germanium, above which again a silicon dioxide which acts as insulator. Above which a silicon, then a gate is deposited. Gate is made up of polysilicon layer, polysilicon. This is the flowchart of our fabrication. First we will pattern the bottom gate electrode, then we will grow a high quality bottom gate insulator and silicon, over which we will deposit silicon germanium channel layer by CVD process, then perform recrystallization of layers. Grow or deposit the top gate insulator, form pattern the top gate electrode. Dope the drain and source diffusion region according to which type of MOSFETs we want. It is doped with either N plus impurities or P plus impurities. Then we will self-align the silicate over the source, drain and top gate if so desired. Then we will passivate. It is nothing but metal coating and bringing out the leads for external connection. Background art just gives a brief view about why thin film transistors are used. That is nothing but thin film metal oxide semiconductors. First, the BiCMOS and SRAMs use the cell size below 20 micrometers. They had low standby currents and high cell stability and lower operating voltage. When conventional TFTs were used as loads, to meet the density standby current, cell stability and soft error immunity requirements. Here they had high threshold voltage and lower mobility, due to which we used TFTs which had two gates, and we tried to provide better on current and on off current ratio. On current is nothing but if we consider a switch, when it's switched on, the time taken to switch on and switch on, that is on current or off current ratio. Next, the disclosure of invention. It is nothing but the present invention comprises one or more relatively thin layers of SiGe sandwiched between layers of silicon. The first figure which I depicted showed this. That is nothing but we had a silicon layer and a silicon germanium. At the bottom we had another silicon layer. That is being explained in first statement. And next silicon layer formed an insulating substrate and are doped to form source and drain region to thereby define a channel region. Channel formation at zero gate voltage. No channel is being formed. When we increase the gate voltage, there is channel formation, but there is no flow of current. Main intention of the device, there should be any flow of current. To provide flow of current, we have to have some potential difference between 2 points. That is between source and drain. So conductivity enhancement is done by providing some potential difference between source and drain regions. Next we have total TFT body. Thickness is scaled down. A major portion of minority carriers will automatically be confined in silicon germanium channel layer, which will result in very high on current. As I mentioned earlier, we had on current difficulties in case of conventional MOSFETs, but in this case we will be trying to increase that on current. The total TFT body thickness in the first statement refers to nothing but the semiconductor layer sandwiched by the gate insulator. That is nothing but the silicon layer first time. Silicon layer, silicon germanium and silicon layer which is below will be scaled down. It means that if we consider previously we had 3 nanometers of that layer. If it is scaled down, it means that we are decreasing it, 1.5 nanometers. If we call it scale up, we will increase it to some 4 nanometers or 5 nanometers. Due to which we will try to enhance that on current. And conclusion?
As my friend has told about some of the structure of TFT, now I am concluding by saying some of the applications of TFT. TFT is mainly used in flat top panel displays, that is in computer panel and or TV panel, etc. And active matrix or liquid crystal display are leading in flat top panel displays, and these displays are mainly used in laptops, and the main applications are those in areas where flexible substrate or large area is used, where there is no semiconductor processing is required, and in these type of parameters, in these type of devices, the device parameters like current and speed are not critical. And now I am going to explain about some of the uses of TFT in the future. And the development of thin film transistor is with respect to the plastic substrate is still under the infant stage, and the second thing is there's a lot of significant scope in the fabrication of ultra low temperature polysilicon TFTs, and that ultra low temperature fabrication is compatible with the flexible plastic substrate, which is under development, which is developed by the TFT technology at the UCB. And the goal is to achieve the polysilicon crystalline transistors where the current exceeding capacity is more than that of the conventional amorphous polysilicon TFTs, etc. And now I would like to acknowledge the college and the department for setting us a platform to express ourselves based on the required topics, and I would like to thank my friends who have put their hard effort for this presentation. Thank you.
What is the normal temperature of the so degrees is boiling temperature of water. It is ultra low. Yeah, what is the normal temperature of solution? Hot is
time which is less compared to normal offers. Normal offers we had physical resistance.
So much less. How faster?
It's faster than offers.
What is the invention date? When was this invented? The variation of quite some time.
Image parsing should be
Very good afternoon, all. So I'm here to talk about image parsing. Image parsing is one of the pre-processing which is done before the actual image processing is done. In image parsing, it is actually you take up an image and then you decompose a given image into its different layers. The layer that we're talking about is texture in the image, the various colors, the background, the text. So you are basically differentiating it into various segments depending on certain characteristics or parameters. So in this presentation, we will first look at the techniques involved in image parsing and its application and various challenges that are encountered while we do this. Actually, image parsing is basically used when you have to do any recognition or detection of a certain specific object out of a complete image. So, for example, we could talk about the recent MS-370 crash. Say a satellite found an image in the water of certain debris of the crashed aircraft. So, how does this satellite actually detect that this debris is of this aircraft? So, for that we actually need to the image is there, but how do we segregate or read that image or analyze the image? That's what image parsing does. So it takes up a given image, differentiates that image into various constituent objects, and differentiates the text, the texture, and certain boundaries that allow us to have further analysis about the object. So this can be used in reconnaissance, spying, medicine, architecture. So now we look at the various techniques that are being developed to image parsing. So image parsing is a decomposition of the image into its constituent patterns, and this finds use in a variety of fields, like I mentioned, architecture, military, augmented reality, facial recognition, etc. So in military it is used basically in aerial imaging, and architecture they use it in case they need to remodel any particular building. Then they parse the image of the building and try to make changes first in the image and then try to actually construct a building. So that is how it's used in architecture. Augmented reality, as in, for example, there are certain softwares now being developed which work on your smartphone. So you take out your smartphone and move the camera along a particular route. So the software actually reads the objects that are present in the room by parsing it. It parses the image of the entire room, differentiates the various objects that are present in the room, and tries to make changes, as in it tells you whether a sofa that you're trying to buy will actually fit into the room or not. So it first parses the image and then
further runs any other application or algorithm that actually do the work that you want it to do. So image parsing actually acts as the first step to other algorithms. So for example, you can take a football match. So parsing, I think, is segmenting it into the foreground, the person at the front, the background, as in the sports field at the back, and then the other fringe of the image. So when you talk about the person, you again do facial recognition, and then you do textural recognition as in the texture of the image, and the same way goes to the color of the image, the contour, the curves that are present in the image, the depth analysis, and that's what happens in image parsing. So what are the principles involved? There are three main principles that have been used to write algorithms. One is you do it extremely meticulously. You take pixel by pixel and try to label each pixel. So that is the first method where you estimate the labels pixel by pixel. And the other thing is you group the image roughly into segments and then try to analyze each segment. Or the third one is another extremely technical aspect where you actually bound boxes, as in you take certain objects that are extremely clear or very much in front, and those are bounded as object bounds, and those are first analyzed, and then you move on to the background analysis. So in this manner, actually it is extremely slow. Image parsing is extremely slow because you need multiple detectors. You need one detector which will analyze only the texture, and another detector that will analyze the shading or the color effects of the image. So it is extremely slow because you need multiple detectors to actually get the complete information out of an image. And we talked that the image is going to be analyzed with certain parameters, but how are these parameters going to be obtained? These are obtained by drawing the histogram of the image. You have certain algorithms which bring out histogram, which actually plot the histogram based on certain parameters. Say I want to talk about the clarity of the image, there will be separate histogram drawn for that. If I want to talk about the contrasting in the image shading, then there will be a separate histogram. And all the data of the histogram will be utilized by the image parsing algorithm, which ultimately segments the entire image. So the brain actually is the best image parser that is available now. So you cannot match the processing speed of the brain. It can process any image that is seen in a fraction of microseconds. So all that we can do is write algorithms that actually match the brain's efficiency or its timing constraints. So when we write algorithms, we always come against challenges. And so one of the major challenges would be image segmentation, which the brain does amazingly well. So in image segmentation, it's extremely difficult because we've already segmented the image into pixels. So we need to take a pixel into consideration. So what happens in image parsing is you take each pixel and try to label it depending on various characteristics. If there's an image which brings about say the color green, then you divide all the green pixels out of the image and label it, and that is how you segment or parse the image so that you can analyze various segments out of it due to some basic characteristics. So applications, the first application I would like to talk about is facial recognition. Facial recognition as in human poses or expressions of the face will be analyzed by using image parsing, and that would be the first algorithm used before we actually come across the facial recognition. The second one would be aerial imaging. In aerial imaging, what happens is the problem of depth or perspective, because even really huge objects look very small and occupy very less pixels. So that is the difference or the difficulty when it comes to aerial imaging. Moving on, we go on to the challenges. The first one, as I said, is facial recognition, where you have to analyze the pose and expression. It is not very easy to parse an image and then you need to filter through a database so that you analyze each pose and expression. So this does not usually match, because we cannot always have a database of every possible pose or every possible expression so that we can end up analyzing the image. So that is our first constraint. The second comes in the edges. So every image, when you segment it or break it into regions, you always end up with edges. And these edges are ambivalent regions. They neither belong to the foreground nor belong to the background. So it is extremely difficult to analyze edges. The third is highly variant configurations. The problem arises when a very simple object can be placed in different orientation or configuration. So what happens, even though it's a very simple object, because of its orientation or the way it is placed, or because of the lighting or shading, the algorithm may not really understand what it is seeing. So that is a difficulty, because we cannot really think about every possible configuration of every possible image or every possible object in an image. And the next thing is multi-resolution, which comes up in aerial imaging, as even some objects use very less pixels. So you have some objects that occupy just 10 pixels, but some objects will occupy 100 pixels. So the variation in depth and to teach the algorithm to actually understand what you're seeing, that poses difficulty because of the multi-resolution that is used in pixel technology. The last thing is the coupling constraint. The main criteria here is that you're analyzing the entire image. So if you have arrived at an understanding for one segment of an image, it needs to hold good for the other segments of the image too. So we need to make sure that there is coupling between the various analyses for different segments. So that is what image parsing is, where you're actually segmenting an entire image and making sure the entire analysis stands, or your entire judgment should stand, and you cannot really judge an image based on analysis of one particular segment. You need to make sure that the analysis of every segment is very sound and actually has proof of why the algorithm is analyzing this segment for this particular object. So in conclusion, it is used to reconstruct an image, and even though several limitations do exist, but we really do not have an option. We need to use this algorithm or this technology as a preprocessor for image processing, because as far as we know, there is no particularly efficient method. The algorithms used depend on your application, on why you really need to do image parsing. So there are various kinds of algorithms, various types of logic that are used for image processing, and that the way you choose it depends upon the application that you're using it.
Broadly, there's one for top-down first and one for bottom-down. That is a classification.
But it differs from person to person. Say if I'm doing evaluating, the algorithm I use will be different. If I'm
Not to any of such algorithms.
they will not really do that long. So only the law.
The algorithm.
One is top-down, other is bottom-down.
There's the approach. Okay, you can implement one algorithm either using top-down. We are not asking you how it works. Name some algorithm which helps for this process. Name some algorithm. Name of the algorithm which helps this process.
Only we compose in a image, there is a text, there is a texture, there is a shade. How do you identify it is a shade, it is a texture?
Some algorithm.
Next, variable technology, lighting.
Myself, graduate from 30th years, and my team is Harshita and Neeta. And our topic is on wearable technology applications. The content of this presentation is going to be introduction, the basic introduction of the wearable technology. Next comes wearable technology in everyday use, the devices which you're going to use in everyday. And then comes the wearable technology in the field of medicine. In the field of medicine, the devices which are used, the wearable devices which are used. Then comes conclusion. The introduction to this wearable technology, that idea tells us that we can access the devices with hands-free, and there will be no longer need to carry around the bulky devices. And a thought, which is man-computer symbiosis, that just gives us a hope that in not too many years, human brains and computing machines will be coupled together very tightly, and this resulting partnership will think as no human brain has ever thought, and it will process the data in a way which is not approached by any of the information handling systems. And till date we have seen only machines that sit on a desk and interact with the user only for a fraction of the day. But it will be more convenient for us if the devices is with us all the time, every day, and they come with the wearable computers. With the current accessibility of the wireless local area networks, it is becoming clear that the computer should act as an intelligent assistant to the user. And it is rapidly becoming apparent that the next technological leap is to integrate the human and the computer in a non-invasive manner, and this leap will lead us to the fascinating world of wearable computers. Okay, now we'll discuss the wearable computing in everyday use. First we cover the fabrics. This computerized clothes will be the next step in making the computers more portable to us without having to carry a plethora of gadgets in our pockets. And for this purpose, researchers are using silk organza, which is very ideal for the computerized clothing, which uses two fibers. One fiber is just a silk thread, and another fiber is a silk thread wrapped inside a silk copper foil. And these two are electrically conductive. And apart from this, we also have the DuPont companies also come up with a different kind of fiber, which is called Alacon, which is made up of Kevlar. And this fiber is also electrically conductive and it's very strong. And we have architecture. One way of architecture is just given here, the MVIT project, which was conducted in 2003. And the main goal of this project was the development and prototyping of new techniques in human-computer interaction for body-worn applications. The visual hardware platform combines body-worn computation, sensing and networking in a clothing integrated design. And the visual software platform is a combination of user interface elements and machine learning tools built on the Linux operating system. Then comes the mobile assistant 5. The Zygonaut company came up with this mobile assistant 5, which is a super lightweight wearable computer. Using this we can send or receive text messages, and we can send or receive mails. We can set reminders, we can make appointments just using the voice recognition technology. Then we have Bluetooth ring. The Lockhart came up with this Bluetooth ring, which is like a magical band on a finger. Just yeah, there are no okay, it's like a magical band on a finger. It recognizes the finger gestures, and with those gestures, it can control many other devices. For example, just drawing a musical note in an air, it can access the musical player of the mobile which is connected with. Then we have a NIMI. It's a wristband which uses the wearer's heartbeat as a unique signature to authenticate identity, potentially converting this wearable as a mobile wallet. That's a NIMI. Then we have Fin. Indian startup company has invented this, which is Cochin-based company. This Fin is a very trendy gadget you can wear on a thumb, which literally converts our palm as a digital touch interface. And this Fin is fitted with a lot of sensors, and these sensors can detect finger taps and swipes and identify various parts of the palm just to calculate the distance from the thumb. Then we have again, we are well aware of this Samsung Air watches. Okay, Samsung Air was first introduced with the Android operating system. Then for the K2, it was the Samsung switched back to its original OS, which was Titan. And the camera in this Air watch can take photos or record videos, and it can be stored in the device's internal storage, or it can be immediately transferred to the user's phone or tablet. A media controller for music or video being played by phone or tablet is also provided, and phone calls can also be answered or placed using this watch. Then we have Google Glass. Google or Project Glass. Okay, the Italian Luxottica company struck a deal with Google to develop these Google glasses, or also called Project Glasses. This is nothing but a stamp-sized screen attached to a pair of spectacle frames, and it has a small camera, and it can record video, it can access mail, and retrieve information from the web, connecting wirelessly to your user's cell phone. And this was all about the wearable devices which we can use in our daily life. Now for medical, this smart jacket is for what I told about the fabrics. This using the mitral architecture, and then this is the hardware of that mitral 2003. Then we have mobile assistant 5, and this is a Bluetooth ring which we can wear where on a guest store, you just can control other devices. Then you have MVIT, which is a wristband, and which makes the user's heartbeat as a unique signature. Then we have PIN, and then we have Samsung Gear watches. This is a Google Glass. Now I go to medical applications. My pen fits. Going on to the medical applications, the impact of wearable technology in the field of medicine has revolutionized the way the medical field is being impact of wearable technology in the field of medicine has revolutionized the way the medical care is provided currently. By creating the devices that are intimate to the body, it is now possible to know the state of our mind and vital health stats. And then the aids for the impaired vision patients which cannot be corrected using eyeglasses can be corrected using some of the wearable computers that integrated to the eyeglasses. Then research has been done in the creation of devices that can perform real-time American Sign Language recognition. This would facilitate the user to communicate with the common people. Then a navigation system is created that is essentially acts as electronic seeing dialogues to help the blind patients. This will constantly guide the user to navigate based on the static or dynamic data. Then environmental conditions and landmark information can be processed and transmitted to the user via detailed voice cues. Whereas acts as a receiver for the standard heart rate monitors, then it will communicate wirelessly with standard medical systems like blood pressure cuffs, scales, etc. Then going on to the conclusion, wearable computing technology today can be considered as a very exciting field and very much expanding, and the future of it is absolutely immense. Well, a great deal of work has been done to create the computers, that is wearable computers, for easy usage and comfortable to wear and provide the user with many different functionalities. Then the wearable devices are being used in the medical context to improve the quality of life of both visually and hearing impaired patients, and also to the patients who require constant monitoring. Then we cannot expect the devices to be 100% efficient, and there has to be there are some limitations. This can be used with factors like battery life, processor power, then display brightness, and this vector has already seen the surface of the wearable technology, and it also poses threat to the privacy of the common people. Some sensors and all that, it gives the information about the blood glucose level and all. How does it read the glucose level and then give you the information of this?
data mining. Data mining is the process of analyzing different types of data and summarizing it into the useful amount of information. Big data mining, it is the capability of extracting the useful amount of information from the large database. And we can see that from the past years, like Google is sharing about 2,000 data, and Twitter it has over 1 lakh views, etc. So the word, the data, big data, from what it has come from. I have some history, like the data, big data, it appeared first in 1998 in the Silicon Graphics slide deck by John Marshall with the title of Big Data and the Next Wave of Infrastructure. Big data mining was very different from the beginning, as the first book mentioning the big data is a mining book, appeared in 1988 by Wes and Hill. The origin of big data is due to the fact that we are creating large amount of data. The Google around 1 billion in 1998, it was reached 1 billion, but the web page index by the Google were around 1 million in 1998, but now in 2000 it reached 1 billion, but in 2014 it has been exceeded to 30 trillion. With big data, there are some characteristics. It basically based on 3 vectors. Big data vector, that is volume, variety and velocity. By volume means as enormous amount of data is being stored, so the volume is increasing day by day. Variety, there are various type of varieties as our data is being stored, that is in the form of text, images, audios, videos, etc. Velocity, as we are interested in obtaining useful amount of data in real time, so now there are 2 more factors based on variability and value. Variability, there are changes in the structure, and the main thing is how we have to interpret it. The same as the volume, as value. As the enormous amount of data is being uploaded and stored, so with all the perspective, there is some value that it contains. He summarizes that the definition of big data in 2012 as high volume, velocity and variety of information assets that demand the cost of capital. Big data mining, as enormous amount of data is being stored, so there is a question that how we have to mine the data, that is called the big data mining. It's the capability of extracting useful information from the large data sets. As big data is a new topic, so there are a lot of tools that are used to mine the data. Big data, it is a phenomenon intrinsically related to the open source software revolution, like large companies like Facebook, Yahoo, Google, etc. All these contribute in open source projects. So the infrastructure it deals with big data. The main software is Hadoop, in which several infrastructure tools deals with, like Apache Hadoop. It's software that is basically made based on map reducing model and distributed system called Hadoop distributed file system. As this Hadoop, large amount of data is parallelly stored in that. Apache Hadoop related projects have been done, like Apache Big, Apache 5 and Apache HBase, etc. So also Apache S4, the platform for processing continuous data streams. There is open source initiatives, big data movement, like it includes Hadoop, MapReduce, MATLAB, etc. Some of the open source initiatives, it is having like Apache now, it is scalable machine learning and data mining open source software based mainly in Hadoop. It is implementing on various parts like MON, that is stream data mining open source software development to perform data mining in real time, and various figures and graph HDFS, that is Hadoop Distributed File System. It is a file system that stores the data for commodity machines, very high bandwidth to store large amount of data, and same as Hadoop Yarn for managing the large amount of data, etc. On the top of this, there are open source applications based on the Hadoop software, that is HIve, HBase, and Pig, Mahout, and Scoop, Cozy, and Cascana. Like HIve, it is basically Hive, basically it is for SQL language, and Pig for interacting environment processing data, and Scoop it is related with RDBMS, etc. Hadoop has the ability to scale linearly. It is written in Java and it is run in Linux. This big data, here we can see that it is using so many things like internet storage. Parallelly also we can work in large cases. Some of the applications where we can use big data in business prospective use and technologies, healthcare, meteorological cycles, etc. Now, what is the debate about big data? Although big data is very much essential nowadays, so we can't compare it with any other thing. Big data may be a high to sell Hadoop based computing system. In real time, like in that case, what is important is not the size of the data, it is the recency. It means like it is very much useful. Like we are based on if we want to research something, we are based on what thing we have to search, not for how much data it is coming. A conclusion about the big data from this pic, we can see that a revolution that will transform how we will live and work and think for the big data. It is the big as the enormous amount of data is being increased, how we will see like the data is stored using the concept in further mobile phones, etc.
see in a traditional network structure, all the 3 planes are not physically segregated. They are associated with each other. Whereas in SDN, which my friend will explain later, the planes are segregated. Physically, there is difference between the control and the data plane. Coming into the limitations of the current network technologies, first one is the complexity that leads to status. The network technologies or topologies which use today use a set of protocols in order to establish the connection or send the data between the transmitter and the receiver. For example, in the network, if we have to move the device or add in new device, the IT, which is called the Information Technology Unit, which deals with the telecommunication circuits to establish a connection, that has to touch all the routers which is present in the telecommunication network and reconfigure it or reconfigure the technology. So this is one, and the circuit becomes, the structure becomes more complex. Therefore, it becomes very complex, which leads to static status. Next one is the inconsistent policies. Inconsistent policies, in order to implement any network-wide policy, the IT has to configure the network to add a new device or any kind of mechanism to the network. The information technology has to reconfigure the device, and it has to update the quality of service of each and every device. So that becomes very tedious, and the policies are not the same for every device. It changes from device to device. So as it changes, the cost increases. This is one of the disadvantages. Inability to scale. Here, as the number of devices increases, what happens is the traffic associated with it is very complex. So dealing with the traffic problems is very difficult. And the key operations which are performed more frequently, it requires a different receiving structure at the receiver side, and other operations which are not performed, even they require a different receiving structure. So as a result, the cost also increases, and the traffic really becomes unpredictable. And the vendor dependency, as you can see today, the industries with the growing technologies, the industries are expecting more from those structures and all that. In order to meet their expectations, to release any product or any device into market, it is very important to come up with the marketing strategies, the cost, etc. But this mismatch between the market requirement and the vendor's requirement is making industries very difficult to adopt the technologies. Therefore, the industries, to respond to all these limitations, have come up with software-defined network known as SDN. Let us now look at what SDN is. The research on SDN was started in University of California at Berkeley and Stanford University in around 2008. Now, the basic operation of SDN is the separation of the control plane from the data plane. As we know that the data plane contains the routers and the switches, and the control plane has many services. So it just separates it from the physical device, so that we can program the control plane. As we can see from the picture, the control plane is separated from the data plane, and now this forms the SDN controller. Now, let us look at the benefits of SDN. First one is directly programmable. Since the control plane is a software, now we can program it according to the needs of the traffic. Next is it's agile. Because of the dynamic automation, it can switch very quickly
also used in network virtualization. It helps, SDN helps network virtualization use the data center resource in a much better manner. The fast turnaround times is creating segregated network from weeks to minutes via automation APIs. Bandwidth on demand. SDN also provides a larger bandwidth on demand. This leads to reduced operational expenses, allowing self-service by customers and increasing agility, saving weeks of manual provision. Google data centers also make use of SDN. Due to the use of SDN, the manageability, the performance utilization and cost efficiency of the WAN has improved. HP solutions, they have deployed a switch which uses the open flow approach along with a controller which uses the open flow approach, which can be used by any of the vendors. They have 40 ports, 40 switches, which is 20 million ports which are open flow capable. An example of this is the HP sensitive SDN security application. Cisco also makes use of SDN. The Cisco solution uses Cisco XLC Nexus 3000 series switch on which tapping is possible. We can build a tapping environment. The traffic is tapped onto the WAN with the Cisco 3000 series switch. On which data can be stored on optical tapes or on switch port analyzer. From this whole scenario, from all this we can conclude that SDN is going to be a very big revolution in the field of networking. It is going to evolve much more and it will make a big difference in the networking field.
You want to put some numbers together, SDN permitted device to any network, how do you define it? Whether it is data handling ability, ease of operation, do you have any numbers for that?
Cloud technology and services by Dr. and Shanta.
What exactly is cloud technology? Cloud computing is the delivery of computing services, inclusive of the software, hardware, etc., to the clients over the internet. So they can be accessible anywhere and to any terminal device like your tablets, laptops, etc., as long as it is internet. The examples of such cloud services include your online file storages, your social networking sites, etc. This underlying concept of cloud was developed way back in the 1950s. It was developed under different names, and in 2007, for the first time, there was a large-scale cloud computing
let's talk about the key features of cloud. On-demand self-service. On-demand self-service is nothing but the provider, when he provides us the product, it is as per to the client's needs. So he caters to the needs of the clients. And broad network access is nothing but, suppose the software is hosted on the cloud, we can access the data from any part of the location, and all we need is a device and internet access for it. And then we have resource pooling. Resource pooling is that multiple users can access the same data at the same time. And rapid elasticity, for rapid elasticity I would like to give an example. Suppose we take a website and it has like around 100 hits per day, and a project is developed on the website and it is altered, and then suddenly it has like around 10,000 hits per day. Now for this, during peak hours of time we need at least 5 servers. So in the presence of cloud, what happens is all the 5 servers are utilized during the peak hours of time, but then in normal time or normal hours, like only 1 server is enough. But absence of cloud, what happens is we purchase all the 5 servers, and only 1 server is utilized, and the rest 4 servers are not utilized, and it is waste. This is a major advantage when it comes to this situation. Measured service, what they say is that it is what we are paying for what we are using. So the provider will bill us according to what network and storage and we are asking for, and will bill us according to it.
The architecture of the cloud. It comprises mainly of the components and subcomponents included in a cloud system. The first one is Cloud Client Platform, which provides an interface wherein the client can interact with the cloud provider via an application or middleware. The second is Cloud Storage at the back end. It's an online network storage where all your data and resources are stored and managed, and they can be accessed by multiple users and they can be modified, etc. The third is cloud-based delivery. These services available on your cloud. They are basically of 3 types: infrastructure as a service, software as a service, and platform as a service. The fourth is the cloud network. The cloud network is one of the most important components of the architecture, and it must offer high bandwidth so that you have uninterrupted access to your data, and agile network so that you are accessing your data in a quick and in a very efficient manner, and network security so that your data and information is protected or secure.
So let's talk about the types of clouds. Public cloud. Public cloud is majorly used for the general purpose over the internet. Private cloud is privately managed and owned, and it is highly virtualized, and it comes with a firewall for safety. And then we have hybrid cloud. Hybrid cloud is nothing but the combination of both the public cloud and the private cloud. Community cloud is like the infrastructure is shared by a set of organizations so that they support a specific community.
Services and its types. The services available on the cloud. The first is software as a service, wherein an application or a software is made available to the client over the cloud, and you no longer have to install your software and use a license, etc. Instead, you just pay a meter fee to your cloud provider. Platform as a service is providing a platform for your client to create new software which can be used on the web. And infrastructure as a service is providing the cloud infrastructure, like say servers, storage, etc. as an on-demand service to the client.
Let's talk about the working of cloud. So cloud technology is majorly about sharing of data and applications via a network. Here the storage is in the form of a physical server which is controlled by a cloud computing provider. The data can be accessed from any location with an internet access. And also, the applications need not have to be installed, and you can use it directly and with the help of the internet access. And cloud usually uses like twice the storage of devices, and as it makes a copy of the original storage, which acts as a backup. Usually the backup is known as the redundancy.
Advantages of the cloud. Firstly, it's highly cost efficient. You're paying for only what you're using, plus there is a reduced expenditure on your infrastructure, etc. So there's an overall cost reduction. Improved accessibility. Since your data, resources, etc. is on a cloud, you can access it from anywhere with an internet, and through any terminal. So it makes your data, etc. highly accessible. There's backup and storage. Since you are storing the data on the cloud, you no longer need physical storage devices which will occupy large amounts of created, it ensures that you don't lose your data. Scalability and performance, this technology is highly flexible and can be scaled up and down to meet the requirements of the client. And minimizing licensing of the new software, this is because you no longer need to buy the software, install it, use the license, etc. You can use it as an application directly from the directly provided by the cloud provider, so you don't need the license. You don't need to license.
Let's talk about the disadvantages here. Technical issues. Thing about cloud is it needs high-speed network broadband. So usually in developing countries at remote areas, we usually don't have high-speed network. So that's one disadvantage. And then we have high dependency. Here the clients are highly dependent on the service providers, which makes the clients more vulnerable. And then we have security. Potential security and privacy has always been a major disadvantage, as we put sensitive data on a cloud. And then we have limited control. Limited control is that we already said that cloud is on-demand self-service, but sometimes we might have to compromise and adopt new solutions, as it might not be as per to our needs. The provider might not provide the product as per to our needs.
Security on the cloud. There's always potential risks in putting vulnerable and sensitive data on the cloud. There may be chances of data leakage or tracking, hacking, etc. There's also a major concern of function creep, wherein your data which you're putting on the cloud can be utilized by the cloud providers themselves without the knowledge of the client or without your consent. However, this is kind of improbable because the cloud providers live and die by their reputation. So they try to keep the best security on the data and the resources stored, and they also take up measures like authentication, wherein the user gets a username and password, or authorization, wherein the user is allowed to access the data and applications only relevant to their job.
So of course, after all this, we'll have to think about the future of the cloud. Recent surveys say that more than 3.5 quarters, that is around 76% of the respondents, they're expecting that hybrid cloud will be the next most strategic cloud, and it is going to take over both the private and the public cloud. And all this is going to happen in the next 5 years. So those are the changes from 2011 and to next 2020.
From this, we concluded that cloud computing is one of the fastest growing parts of IT. It's easier to acquire, scale up, scale down, and it can be used for most of the applications, but not for all the applications. And we hold some very strong promises because they are highly available, the resources are dynamically allocated, and the clients pay for only what they are using.
We thank the department for a wonderful opportunity. Thank you.
contents are virtual reality, applications, gaming, biosensing, Second Life, Oculus Rift, and challenges in future. Now first let us understand what is virtual reality. Virtual reality is also known as immersive multimedia. Virtual reality can be defined as it is a computer generated three-dimensional image or environment which can be interacted with a real or a physical person by means of electronic devices such as helmet with a screen inside, data gloves with sensors, etc. Then most of the current virtual reality are associated with computer screens or special type of stereoscopic screen displays, etc. And also it has got special sensory information types like sound with help of headphones and speakers. Then, according to the metaphysics of virtual reality by Michael Hartman, the concept of virtual reality is divided into 7 steps. They are interaction, simulation, artificiality, immersion, telepresence, full body immersion, and network communication. Virtual reality has a wide application associated with high visual, 3D environment, and immersion. In this, we can immerse. It is immersive type in which we can. It is immersive computer generation in which we can involve ourselves in the surroundings of our own types. We can also have a lot of. We can explore the uncharted territory of human imagination. Now, let us discuss what are the applications of virtual reality.
Virtual reality basically offers a large range of potential uses. It's used in many fields such as architecture, fashion industry, medicine, training, military training, etc. Now going in depth with medicine, it's used to perform surgeries on a remote patient and then to practice surgeries. For example, the surgeons practice operations to be performed even before they're performed on the patient. Then they're also used to treat people suffering from various phobias and to treat people suffering from entertainment. The entertainment industry is one of the most enthusiastic advocates of virtual reality. Apart from gaming and virtual worlds, it's also used in many other areas such as virtual museums, galleries, then theaters, filming, etc. The main purpose of this is in the field of entertainment, whose sole purpose is not only to entertain people, but as well to educate them. Here we can see pictures of theme parks which use the concept of virtual reality.
Now we are going to talk about computer graphics. If you want to make three-dimensional objects or write VR programs, we need to have a specific program. The specific program is called as VRML. It is visual reality modeling language, which helps us to design animation and three-dimensional objects like geometrical shapes. And then it allows us to view the 3D scenes and manipulate it via internet. And then the user can also go to the VRML website and use it by using a VRML website. And then you can also enter the 3D world and experience it. And then now we will talk about the virtual reality gaming, which is the most amazing feature in this field.
Virtual reality gaming is the most fascinating feature of virtual reality in general. What is virtual reality gaming? It is where a person can experience a three-dimensional environment and also interact with this environment during the game, even though he's not physically present there. Now, how does virtual reality gaming actually work? The main concept behind the working of virtual reality is biosensing. What is biosensing? Biosensing is nothing but, in simple words, is a way of detecting a person's presence in games. So a biosensor is one which can detect and interpret nerve and muscle movements with a properly calibrated biosensor. A computer is used here which interprets these signals and transforms corresponding motion in the real world into virtual world. Here you can see a virtual glove fitted with plus fitted with biosensors. These biosensors help in detecting the movements of users in real world and then transform it into virtual scenes. Now these movements are then fed back to the computer which analyze the data and use this to transform your actions into appropriate responses on the computer screen. Here you have even pictures of bodysuits in the head-mounted display which are fitted with biosensors. Now moving on to top 10 virtual worlds.
Top 10 virtual worlds are like in the field of sports, role-playing games and war themes. The top 10 are listed here. There are Second Life, Empire of Sports and PlayStation, Kenema, etc. The most important in this is Second Life. Second Life was created in the year 2003 by London Lands. Here we can make our own avatars in the form of whatever you want. It may be human or animals, birds or anything. And then this is the most famous where you can interact with other people all over the world. You can visit different places according to the level. But this game was very famous in the past few years. But after the advent of social networking sites such as Facebook and Twitter, it has lost its favor and now its popularity has been downgraded. And then Oculus Rift. Oculus Rift is a device invented by a company called Oculus VR. It is a virtual technology company which was founded by Palmer Luckey. And then its first product was Oculus Rift. Oculus Rift is a head-mounted display for immersive virtual reality. This company was this 10 days ago, that on 25th March, was purchased by Facebook for $2 billion US. Now you can see that Oculus Rift is used in Blue Shark operation, and this is a game wherein virtual work on Mars. It is used in the Philippines.
Now moving on to challenges and concerns of virtual reality. One of the major challenges of virtual reality is to develop better tracking systems, and also this gaming is quite expensive, so we should come across with measures which could reduce the cost later. And cybersecurity is something which we all are familiar about. It's like the user gets so addicted to it that he starts to blur the boundary between the real and virtual worlds. So these are few ethical issues which have to be addressed in the future.
Now coming to scope of virtual technology in the future. It has got various applications in the future. The main drawback of this is the pricing. The cost is so high that only the research labs and the companies having research and development sectors can afford this type of technology. And then in the future we hope that the price comes down because the components have become more affordable and it's become accessible to the various people all over the world. And then this is the graph which shows the growth of virtual worlds from 2005 to 2012. It's having a drastic change, and then we hope in virtual world in the future we will have such a state that we might not differentiate between the real world and the virtual world. Both will look alike.
Summing up, we would like to tell that virtual reality is offering us a new way to interact with the computer, and there's like high scope of its development in the near future. And then it's changing our life, and virtual reality is increasingly becoming a part of it.
very interesting topic called microelectronic film is presented by Narayan sir and myself, Monica ji. A microelectronic film. If you see, our human body is very sensitive. Any small microbial change or a virus change inside our body gives a lot of change in the sense a small microbial activity inside our body is hard to detect. Say the disease is not detected very soon, is difficult to cure. So the basic step for any treatment of a disease is its detection or the diagnosis. So in 1972, when transistors came in vogue, gastrointestinal tract, the physiological conditions of it was discovered for the first time in that time, 1972. Gastrointestinal tract is in a very remote axis because if you see, endoscopy also exists. Endoscopy is a technique where the internal organs, how it works, is detected with light and a camera fit to it. So when already endoscopy exists, why go for a microelectronic pill? So a microelectronic pill is basically for its remote axis, and as the name suggests, it's a pill and it consists of sensors, so it's a sensor pill. And this pill is taken by a patient, and when it is consumed, comes out of the bowel movement, natural bowel movement after 24 hours. So the principle behind it is a microtechnology, and let's see what are the contents for today.
Then what are the need for the sensors? What are the sensors we are using? I go to what are the sensors we are using. First comes the temperature, and then that is done using silicon diode, and then the temperature sensor is used to make out the difference between the internal body temperature and the external body temperature. Seeing that, we can take a track and decide the path, the way the micropill has to go and then attack. And then pH level, that is done using ion select field effect transistor. pH level, as pH meter we know, like 0 to 7 is acidic, and then basic, and 7 to 14 is an acidic one. So seeing that it is both used for internal and then external. If the pH level is too high, then the diseased microbial activity is too more. And then if pH meter is once again high, it may affect the device. And then conductivity. Conductivity is done using direct contact gold electrode. And then this is used to measure the salt and then water absorption level inside the gut. And then dissolved oxygen. You might ask, why do we need the dissolved oxygen? So oxygen is the main medium for the life. So if the oxygen content is more inside the intestine, the microbial activity is more. There is some sort of life. And then this is the block diagram and the major part. So control chip, it consists of a microprocessor, program, and then biocompatible capsule encasing the microsensors. And the biocompatible capsule is made by PEEK, that is polyether turkitol, which is more less reactive compared to plastic, and it is very fastly biodegradable. And then radio transmitter. Here the radio transmitter is designed in such a way that whenever signal is need to be transmitted, it is transmitted to the base station and then to a lab. So for example, if a case is outside the lab, even then we can detect, or even then we can monitor the case. And then two silver oxide cells, which is a battery, which is a main powerhouse of a cell, and then compact cell which has microsensor, which I told you in the. And then this is the main pictorial diagram. Towards my left side is a battery unit, and then pH sensor, and in between we have a microprocessor, thermal, and a radio thing. And here is a drug reservoir. As not only for monitoring, here we can have some of the drugs which are useful to
eliminate some of the diseased microbes inside. So there is a fluid pump which has a step motor in it. If we detect any dangerous microbial activities inside, so we can control it using some drugs, and it is done through the fluid pump.
So if you break open that pill, this is how it would look like. Since it's a four-channel pill, there are two access channels indicated by the two arrows. The entire microelectronic pill is about 55 millimeters. It consists of a PCB chip carrier which is going to carry ASIC, which stands for Application Specific Integrated Circuit, and two sensor chips which are controlled by the control chip. It has a transmitter, a connector, and two batteries. There are two types of transmitter, type 1 and type 2. Both of them work in a similar manner, but the footprints are different. Footprints as in how the length, breadth and height changes. It is according the type 1, it has 8 cross 5 cross 3 millimeters. The type 2 consists of 10 cross 5 cross 3 millimeters. 1 is actually indicating the access channel. 2 is the place where all the sensors are placed. 3 is an encasing, and to hold it in a place we make a rubber bure ring. 5 is ASIC, 6 is the PCB chip carrier, and 7 is the transmitter, 8 is the battery. The battery is actually placed on the rear end, which is indicated by 9, and the similar layout is done in the type 2 as well, but a different radio transmitter as indicated by 10. So the control chip, the main feature of this will be, for any electronic device we take, is how much is the current consumed and the power. So the current is very less used, around 1.7 milliamps, and power of about 5.3 milliwatts. The entire control chip, the 4 sensors are sent to the application specific integrated circuit. Like if any change in the voltage or current, it is sensed, and accordingly we get to know how much is the change in the temperature or the pH or the conductivity or dissolved oxygen with the change in the fixed voltage or the current. All this will be sent to, all these are analog signals. So they are sent to a mux and then later to a DAC, analog to digital converter, then digital to analog converter. We need a oscillator for this, which will operate at 40 megahertz, and all these signals are transmitted to a radio transmitter, and battery is powered. So the radio transmitter is actually operating at 40 megahertz, as told earlier, at 20 degrees Celsius, and it has a modulation scheme of FSK. Next. These are the kind of observations we can obtain in the lab. The first one shows if the temperatures are recorded from around, it has a range of 20 degrees to 70 degrees, or 0 degree to 70 degrees Celsius it will work. So these are the kind of graphs we can obtain. Only temperature if you want, only pH, or if you want to combine and see at a particular temperature what is the particular pH we want. This is shown in the 4th diagram. These are the other types of pH level and varying with the temperature diagrams found. 2 silver oxide batteries are required. These are the hard, because without a battery none of the devices work. And this battery device, 2 of them are required, which has a supply voltage of 3.1 volt. And the main feature of this will be operating time. It can operate around 40 hours. Next.
And then range and then accuracy. The range of the temperature where it can work is 0 to 70 degree. And the pH till now it is from 1 to 13. And then dissolved oxygen up to 8.2 milligrams per liter, and conductivity above 0.07 milli. Full scale dynamic range analog signal up to 2.8. It can work out, it can operate up to 2.8 volt signals inside it. And then accuracy, pH channel around 2.2 units above the real value. And then oxygen sensor, which may vary plus or minus 0.4 milligrams per liter. And then temperature and conductivity within 1%. And then main advantage is whenever it's not in use, it goes to the standby mode. So the battery is saved, and then the long life of the cell is around 40 hours, almost 2 days, and then it is very high sensitive. Even a small reaction or a small change inside the body is detected through it, and then it consumes less power, less current, and less voltage. So it, and then we come to disadvantage. It can't be worked, it can't perform its full potential under ultrasonic and then impedance tomography, and can't detect any radio abnormality. For example, if a person is working in nuclear reactor and he has some diseases, through micropill we can't be able to fully extently help him. And then micropills are very expensive. As comes the M factor, it is very expensive, and then still, even though the pill is so small, it can't be digested by small babies. And further,
other than human bodies, it can be used in environment, where environment as in if the pollution is there, how much is the amount of pollution or water quality, like hardness or the softness of the water can be determined. Inside manufacturing process, inside the pipelines, how much is the hardness, the corrosion, all can be detected using the microelectronic pill other than the body. So as a end, what I can give a take-home message is, as and when our diseases are changing, technology is also changing. Say 10 years ago, where polio was such a major disease, now India is a polio-free nation. In 10 years, we can predict that cancer, which is now a deadly disease, can be made a chronic disease. That means we can actually live with cancer. So ultimately, what kind of disease we are going to get is unpredictable. It is a new challenge. So ultimately, what we have to do is our health system must evolve to meet the new challenges. These are the references. It is an implementation from the IEEE paper. Thank you.
What parameters or diseases of the brain?
all they don't have
Everything is gastrointestinal tract, even the bile secretion, if it is excess or like that.
What is your
till the nearest space station.
Sir, the radio transmission.
ನೈನ್ಗೆ ಒಂದ್ಸತಿ ಹೊಡೆದ ನೈನ್ಗೆ ಒಂದ್ಸತಿ ಹೊಡೆದ ಏಯ್ಟಿಗೆ ಫಸ್ಟ್ ವರ್ಷಕ್ಕೆ ನಾನು 10ದ